All right, hello and welcome to the SOC Level 2 training series. We're going to do this one a little bit different than what we normally do on this channel, and I'm going to make this a part of the complete series. So as a part of the SOC Level 2 training inside of TryHackMe, we have several modules. As you can see here, we go from log analysis to advanced Splunk to advanced ELK stack, detection engineering, threat hunting, threat emulation, incident response, and malware analysis. And each one of these modules have several rooms inside of them. So this is going to be a very robust training series, and it's going to involve probably several dozen videos at the very least. And we're going to kind of keep it in obviously one big playlist, and everything's going to be connected to each other. And I'm going to label these things. I'm going to number these episodes so that you have a bit of a consistency, and you know where everything goes and how to follow along with this whole thing. And as a part of the very first video, or the very first video, is going to be the intro to logs video that's going to be inside of the log analysis module inside of the SOC Level 2 pathway of TryHackMe. And then we're going to do log operations and intro to log analysis inside of this specific module. So without further ado, let us actually jump into the content of this particular episode. But first, real quick, if you haven't already subscribed to the channel, would love to invite you to subscribe, like, share, comment, all that good stuff to Hank Hackerson at Hank Hacks Hackers. And this is a very great channel in my opinion, and based on all the comments that I've gotten so far from the community has been growing very steadily over the last couple of months that we started this channel. And I have decided that I'm going to actually reveal my identity when we hit 100,000 subs. So I know it's a little bit of distance away, but I think based on the growth spurt that we've had, it won't be too far along into the future for that to actually happen. A lot of great channel content, a lot of great stuff going on in the comment section in the community, and we're going to open up memberships pretty soon as well. So we'd love to have you in the community, and we'd love to have you as a part of our crew here. Now we can actually jump into the content of the video. All right, chances are you've already heard of logs. There's a lot of different types of logs that are collected inside of a system and a network, and each log serves a different purpose. And specifically in the security world, we have a lot of different specific logs. I feel like I'm going to say the word log so many times that it's going to lose its meaning. But they're essentially a record of what has happened on the network or on the system. And there's records for login attempts, there's records for changes made, there's records for network attempts, so many different types of logs. It's kind of overwhelming. I think we're actually going to go into just some of the general names of logs that exist on a machine. But I mean, just for fun, let's do a quick search. All right, so just based on a quick Google search, this is what we got, right? So we have, and this is, I think, specific to security. We got perimeter device logs. And based on that, there's a series of logs that happen. And there's the Windows event logs that has the application logs, security logs, system logs, direct service logs, DNS server logs, file replication server logs, and then there's more categories. So the endpoint logs that are attached to each individual device, there's application logs. I mean, there are so many freaking types of logs. There's proxies and IoTs, Internet of Things, and just there's a lot. This is specific to security, but there are so many types of logs that exist, and you may not have to worry about all of them because you're studying for cybersecurity and penetration testing. So that won't necessarily apply to you, but the security stuff definitely does apply to you. And the stuff that we're going to be talking about is going to apply directly to security. One of the recommended readings is the Windows Event Logs room, which I know I've already done, and there's actually a video for it. Yeah, we have all the check marks here. So there's one for Windows Event Logs, and you're more than welcome to go check that out. That is recommended reading prior to starting this particular room. But I feel like since this is an intro to logs, you may not necessarily, you could probably get by without actually having to go through that. So yeah, that's pretty much it for the intro to logs. I mean, you've already heard of logs. I'm pretty sure you understand exactly what they are. They're essentially just data sources and collections of data points and values that are relevant to what you're going to be doing as a security analyst. So That being said, let's actually go into the first official piece of the content in this room, which is going to be expanding perspectives and logs as evidence of historical activity. All right, in this particular task, we actually have a virtual machine that I've already started, and hopefully it will start up pretty quickly. But until that starts, we can kind of just read up on this specific room here, or this particular task. It goes, a web server of Swift Spend Financial is constantly bombarded with scans from an adversary. As a systems administrator of this organization tasked to address this predicament, you must identify what the adversary is doing by configuring, logging, and analyzing collected logs. The user Damien Hall, which is, I believe, who the user is that we were using, has limited sudo privileges. So we need to find out what kind of commands that we can run by doing sudo L. So list all the commands that we can use with sudo, just so we can find out what we can do with this particular user. I've already started the machine, and we actually just got our username, password, and IP address for this. It contains artifacts to help us better understand logs and the implications of the analysis. So we're going to work on all the following tasks with the logs that are available in this particular machine. Escalation of privileges is not necessary to answer the questions in this room, so we don't need to do anything on the pen testing side. We're literally just going to be doing log analysis and trying to find data and information. So just as a physical tree's rings reveal its life history, indicating good years with thick curls and challenging ones with thin, a digital log provides a historical record of system activity. And there is going to be a lot of stuff inside of a log. So for example, there's the timestamp of when an event was happened, the name of the system or the application that generated it, the type of event that occurred, the additional details about it, such as who the user was that initiated it and the device's IP address, either the source IP or the destination IP, the source port, the destination port. There might be severity level that we can kind of see right here. There's severity level here, descriptions, and a lot of good, interesting information that would be inside of our log to help us understand what's going on. And what logs really do for us is they help us answer these questions here, right? So what happened? When did it happen? Where did it happen? Who is responsible for it? Who made it happen? Were their actions successful? And what was the result of their action? And this may be somebody who's attacking the system. This may be somebody who works for the company. It could be a lot of different types of people who are doing this. It could be intentional. It could be non-intentional. They may not know what the hell they're doing. And there's a lot of things that kind of logs help us figure out. And again, it might not even be an intentional thing. It could just be somebody who's kind of ignorant and oblivious to what they're actually doing, and they kind of cause a little bit of damage within the network. So it's an important series of questions to keep in mind as you go through any kind of log analysis or incident response, because these are literally the questions that you're trying to happen. So what just happened? When did it happen? Where did it happen? Who's responsible? Were they successful for what they were trying to do? Maybe they were trying to log into their account and they had multiple failed logins, and that sent off a flag in our SIM. And then now we're trying to look at it, and we need to find out, were they successful in logging in? Were they successful, or did they get locked out? All that stuff. So now that we kind of understand this information, we're going to go and run through some of these questions with the logs that we've been given, right? So in this particular scenario, we had the adversary that was confirmed to have accessed the SwiftSpend Financial GitLab instance. They accessed it on 22/10, which is basically 10/10, on Wednesday, September 8th, 2023. The event originated from this IP address and with the VPN's user segment for this specific subnet. And upon examining the logs, it was observed that the device identified by the user agent Mozilla, so they used Mozilla Firefox, it seems, and was allocated the IP address that we see here. And yeah, they were successful since the API key was found to be publicly exposed on the GitLab instance. The web proxy logs confirmed that the adversary device reached GitLab's SwiftSpend Finance API and maintained access through their upload web shell. So they got a web shell and they were able to do some things apparently. They achieved remote code execution on that API and performed post-exploitation activities, which could be a variety of different things. So this is what specifically has happened. in this particular incident. And these are the questions we're trying to answer. So what is the name of the colleague who left a note on the desktop? And this is the note that we got right here. And what is the full path to the suggested log file for initial investigation? All right, so here we go. This is our note, and we got somebody by the name of Perry who left this note for us. And it says you could look at the available logs in this particular path, and but I suggest looking into this path and searching for suspicious web browser activity first. So this is the path where the actual logs are, and then this specific path gets us to the access log that we're looking for. So in this particular case, it says, what is the full path to the suggested log file? So this is going to be this one right here that we're trying to give as an answer. So first and foremost, the person who left us the note is Perry, and the path that they left us is this one. And there we go. That is it for this one. So we're going to go and check out that particular log. So I'm going to go and open up a terminal real quick. And I'm gonna go and try to find that log real quick. Okay, so here we go. We have our current directory, and what we're trying to do is we're trying to go into this one variable, or variables, I guess. I don't think it stands for variable, but that's where we're gonna go to try to find that access log. And there it is. So we got the access log right there as well. And just for your information, that's basically all I did. I just changed the directory and I got here. By now you should know how to change directories and do all those things. So okay, so now we are in the place where the access log is. So now what we need to do is we need to move on to the next task, which will probably have us do some interesting things with this particular log. So here we go. Let's go into the types, formats, and standards. All right, so we kind of jumped the gun, or I jumped the gun a little bit earlier in the video, and I looked at some of these various logs, but there's more examples here. So, you know, we have the application logs that relate to specific applications. Then we have the audit logs that are for operational procedures crucial for regulatory compliance, which is a really big deal depending on which industry you're in. I think all industries really actually consider auditing and compliance and regulations very, very important. Then we have security logs, obviously for security, like logins, permission changes, firewall activity, things like that. You have server logs that are connected to specific servers, or not specific servers. They're specifically in relation to servers. So the any kind of server could feed into this. You could probably have a log for each individual server, including the system itself, the event, error, access logs, all that stuff. System logs, so for the kernel, system errors, boot sequences, hardware status. Network logs for network traffic, connections, and anything like that. Database logs for database activity, such as queries made to the database. And of course, web server logs that are requests processed by a web server, including the URLs that were pulled, the response codes, and the types of requests that were made, etc., etc., etc. So understanding the various log types is critical for practical log analysis, and it enables an analyst to effectively parse, interpret, and gain insights from log data, facilitating troubleshooting, performance optimization, incident response, and threat hunting. So log formats. So this is different from the types of logs. So there's a log format, and it defines the structure and organization of the data within the log file. It specifies how the data is encoded, how each entry is delimited, and what fields are included in each row. These formats can vary widely and fall into three main categories. One of them is semi-structured, then you have structured, and then you have unstructured log formats. So we're going to look about that right now. So we have a semi-structured log here, and they contain structured and unstructured data with predictable components accommodating free-form text. So it's a mixture of structured and unstructured data, hence the name semi-structured. And so this is a syslog message, which would fall under this category. And it's a widely adopted logging protocol for system and network logs, which is the syslog, the system log. And so if we just kind of read this log file, this is what it puts out for us. So you have the date and the time, and then you have the name of the web server. Then it's a cron job, so chronological job done by root. There's a command that was ran, and then this is the command. The whole command right here is a pretty long command. And then you have then user start. So I mean, this actually, I think this is the whole thing. Like this entire thing is the command right here. Then you have the Windows event log. The EVTX, what does this stand for? Is a Windows XML event log file. It is a file format used to store event logs generated by the Windows event logging system. Proprietary Microsoft log for Windows systems. So you do a get Windows event and you pull this particular path, which is the path to that specific log file, and it gives you this very beautiful log output. I mean, this one is so much cleaner than this one. This one you kind of gotta decipher it yourself, you know. But this one literally gives you the time in one column, and then it gives you the ID and the level display name and then the message, right? So it's kind of crunched up right here. So this is the message in its entirety, but then it's an information display. This is the ID number of the event. Pretty easy to read. A structured log follows a strict and standardized format, and they're conducive to parsing and analysis. Typical structured log formats include field delimited formats. So these are comma separated values, CSV files basically, or TSV files, which are tab separated values. And this is what it looks like. So you have the time, the user, the action, the status, the IP, and the URI. And so this is what it is. So you have the time right here, the user, the action, the status, and then the IP address, and then the URI that was accessed, right? So it was at this time the adversary made a GET request and it was successful, and it was against this IP address, and then this is the specific, or I'm sorry, not against this IP address. I think this is the status, the IP address of the adversary. And then this is the request that they made right here, and they went to port 80 on this specific domain, and they made a GET request, so they probably pulled whatever they wanted to pull successfully. Then we have the JavaScript object notation, also known as JSON, known for its readability and compatibility. JSON is also a very structured type of a file, and very similar to the other one, except instead of having all of the labels for the fields, it has the label and then the value. So this is the key, and then this is the value technically. So this is the time, and then the user, adversary, action, get, status 200, IP this, URI that, right? So same information, just designed a little bit differently, presented a little bit differently. And then we have W3C extended log format, and this is what this looks like. It gives us a version, which is very cool. Then these are the fields, date, time, and then the value, it doesn't separate for us. So it just says date, time, CIP, C username, SIP, S port, CS method, CS URI stem, SC status, and then we got from right here. So it doesn't give us like a separation of anything. It just kind of, after the last field, you see right here. So this is the date and time, and then we have the CIP, the C username, and then the SIP, the S port, and then get explore 200, right? So they went to the explore directory or the explore path on this specific IP address, and they had a 200, which means success. And then we have XML, so extendable markup language, which is a kind of like a evolved version of HTML. And very, very similar. I mean, I guess not similar, like the information in the fields and all those things are similar, but this one, as you can see, separated by these, I don't know what these are called, greater than and less than signs. I don't know exactly what those called. They're not brackets. Anyways, so we have a log time, or this is the log, right? So notice how this is at the beginning, and then this is at the end, and it's preceded by a / So this is what XML or HTML looks like. You have the initial piece, and then the ending piece is always preceded by a /, meaning that it ends. And so time will also have another one that has a // and then you have user, which will also have another one that has a // then you have action, same thing, status, same thing, IP, etc., etc. And so they very similar, right? They made a GET request, again, some kind of a URL, and they were successful. And this is now an unstructured log. So it compromises free-form text. They can be rich in context, but may pose challenges in systematic parsing, which means it's going to be difficult to sift and sort through them, basically, because they're not structured. So if you wanted to pull the time value, it's not as structured as everything else that we just talked about. So the NCSA common log format is known as the CLF, and it's a standard web server log for client requests, and it's typically used by the Apache server. So this is the log itself, this is the IP address, adversary would be the username, this is the time and the date, and then we have the GET request explore HTTP. It was a 200, which is successful, and then 4886, which I want to say is maybe the event ID that came through on this. So there's no field, right? There's no labels for the fields. You just kind of make your deductions based on what you know and what it looks like. Then you have the NCSA combined log format, and it's an extension of CLF, and it adds fields like the referrer and the user agent, which is the basically what agent they used, what system or application they used to access the information, and who the referrer is. In this case, we have the same IP address, adversary is the username, same time, they made a GET request, and GET explore HTTP 1.1, which is a little bit, no, actually it's exactly the same, and then everything afterwards is new information for us. So we have the referrer in this case, which is going to be GitLab SwiftLab Finance, and then we have the Mozilla Firefox being our user agent, which is what they used. That was the application they used, and it was on an Ubuntu Linux system, etc., etc. So that is the last format for our unstructured log. So we have an important note here that says custom defined formats can be crafted to meet specific applications or use cases. These formats provide flexibility but may necessitate specialized parsing tools for effective interpretation and analysis. So log standards in this case are going to be a set of guidelines or specifications that define how logs should be generated, transmitted, and stored. Log standards may specify the use of particular log formats, but they also cover the other aspects of logging, such as what events should be logged, how logs should be transmitted securely, and how long logs should be retained. And these are some of our standards. So you have the common event expression known as CEE, and let's see, this is actually clickable, so let's see what we can find on this side. This goes to MITRE. So this is the MITRE website, and it gives us all the notes for CEE, including some information on the side right here. So that is a standard developed by MITRE. It provides a common structure for log data, making it easier to generate, transmit, store, and analyze logs. And of course, there is going to be OWASP, OWASP's logging cheat sheet. And if you have not heard of OWASP, you gotta look into it by now, especially because we're in the SOC Level 2 course. Technically, there's a lot of good information that we covered in SOC Level 1. So OWASP, if you don't know what it is, you definitely got to look into it. It's the Open Web Application Standard or Security Program or Security Protocol. Oh, I can't believe I can't remember it. OWASP definition. Let's see. It opened up in a new window. The Open Web Application Security Project. That's what it is. Okay. All right. So that's what OWASP is, and it's a guide for developers on building application logging mechanisms, especially related to security logging. Then we have the syslog protocol for message logging, allowing separation of the software that generates messages from the system. Then you have the NIST Special Publication 892, the National Institute for Standards and Technology. Guides computer security log management. Then you have Azure, which is a Microsoft cloud environment. They monitor logs. Google Cloud, so as the name implies, these are logging for Google Cloud Platform. And then you have the Oracle Cloud Infrastructure logging for logging on Oracle Cloud Infrastructure, and then Virginia Tech Standard for Information Technology logging. It's a sample log review and compliance guideline. So all of these are clickable. Is this room free? It is a free room. So this is actually a free room on TryHackMe that you can get access to without being a paid subscriber. So if you wanted to get access to all of these links, I would highly recommend that you just open up a free account at TryHackMe if you don't already have one. I assume that if you're watching this video, you already have an account at TryHackMe. If you don't already have it, definitely go get yourself one. There's a lot of free rooms that don't require you to subscribe, and this is one of them, and you will get access to all of these little clicks, these little links. So here we go. All right, so based on the list of log types in this task, what log type is used by the log file specified in the note from task 2? So now we actually have to go ahead and look at this log. So I'm just going to do a cat command, and we're just going to print this onto the screen. And let's see, there's a lot of information in here, and if we were to just look at it, there's no labels, right? So there's no field markers or anything like that. So this to me looks like an unstructured log file. But specifically, I think they're wanting this kind of a name. So one of these names right here. So it looks like it has, so since it has the user agent for us, we can do, I would say it's probably, because the other ones, there's no other one that I saw that had a user agent associated with it. So my best guess would be the NCSA combined log format. So let's try that. Oh, you know what? I think I mean, not I think, but I for sure misread the question. So this is what we got to pay attention to specifically. This is asking for a log type. This is asking for a log format. So as far as log types are concerned, we would go to the very, very top, and these are our various log types. And so request processed by a web server, including URLs, response codes, etc. And that's exactly what we have on this side. You have a request that's been processed, including a response code that came through it, and it was obviously Mozilla, Windows, etc., etc. So that is a web server log, is what that is. So there we go. All right. So based on the list of log formats, what log? Okay. So now log format, right? What log format? Oh, you know what? I think it's this thing. So I think that's what it is, because it definitely does. It has literally exactly the same format of information. It is unstructured, but I think they're asking for a specific name here. So let's see if we do combined. Okay, combined worked. Okay, very good. All right, that worked, and we got our information. And now we can move on to the next one, which is collection management and centralization. So let's talk about that. All right, so log collection is an essential component of log analysis. You got to aggregate logs, you got to collect logs, and they come from a lot of different sources. It's pretty basic. For logs to effectively represent a chronological sequence of events, it's crucial to maintain the system's time accuracy during logging. Using the network time protocol is a method to achieve this synchronization and ensure the integrity of the timeline stored in the logs. And this is a foundational step to ensure that a security analyst would have a comprehensive data set to review. The following is a simple step-by-step process. So you identify sources, list all potential log sources like servers, database, applications, network devices. You choose a log collector, and you want something that is suitable for or that aligns with your company's infrastructure. Log collector, I mean, Splunk technically I think is a log collector, although I don't know if I don't know if it's a log collector. I think you can actually set it up to collect logs. No, you know what? We've definitely played with Splunk, and you can definitely set it up to collect logs. We've used it previously to parse through logs and to actually kind of find information, but I know that you can set it up to collect logs from various endpoints, from ports, so on and so forth. So configure collection parameters, ensure that time synchronization is enabled through the network time protocol to maintain accurate timelines, adjust settings to determine which events to log at what intervals and prioritize based on importance, and then test collection. Once configured, run a test to ensure logs are appropriately collected. Important, please be aware that the network time protocol protocol, network time protocol. Yeah, network time protocol. The NTP-based time synchronization might not be possible to replicate with the VM, with our virtual machine, since it has no internet connectivity. However, when performing this in practice, using pool.ntp.org to find an NTP server is best. Time synchronization can be performed automatically on a Linux-based system or manually initiated by executing this command, which is ntp update pool.ntp.org, which is what this looks like right here. And then it'll update. And then if you just look for the date, it'll give you the information. So if I just went here just to test it out, because we don't have access to the internet with this machine, but if I do type in date, it'll give us the actual date of this particular recording, which is well, it's not actually. Today's the 23rd, so this is ahead. So I wonder what time zone this is actually in. Oh, universal. There we go. UTC. So this is a universal time zone, and it's already ahead. So this is in the future. I'm recording this on a Sunday. So all right, here we go. Log management. Efficient log management ensures that every gathered log is stored securely, organized systematically, and is ready for swift retrieval. A hybrid approach can provide a balanced solution by hoarding all the log files and selectively trimming. Once you've collated your logs, effective management of them is paramount. These steps can be followed to achieve it. So you store it, decide a secure location to store it, and considering factors like retention period and accessibility, organization, classify logs based on their source type or other criteria for easier access later. Backup, regularly backup your logs to prevent data loss. Periodically review to ensure that they are correctly stored and categorized. And then you have the centralization. So this is I think this is the big piece right here. This is where a SIM kind of comes in, is where you centralize all of your logs. And this is specifically for quick access to the logs. If you have all of your logs in one central location, you get quick access to everything. You get to do an in-depth analysis, meaning you get to review all of them, and then you can use information from all of the various logs to put together some kind of an incident, or the dots that would make the incident, and then you can respond to that incident quickly. Instead of having to go find logs from different places and manage them and so on and so forth, everything's in one central location, like a SIM, like Splunk, and it helps you even. Splunk actually helps you connect all the dots because it's very, very good at parsing through shit like that. Excuse my French. So a unified system allows for efficient log management, etc., etc., etc. Centralizing your logs can significantly streamline, so you choose a centralized system. It consolidates logs from all sources such as Elasticstack or Splunk, and we've done videos on both of these that you can find on this channel on Elasticstack or Splunk. Elasticstack is the open source version. I believe it's more easily accessible for people who don't have a big budget. Splunk does require that you do. It does have a free version, but it is very limited, obviously. Then you integrate your sources. You connect all of your log sources to this particular system. You set up monitoring that give you real-time monitoring and alerts for any event that might come up, and integrate with incident management devices or systems with any kind of tool, so on and so forth, to help you with incident management. So now what we're going to do is we're going to collect a log with rsyslog, and then we're gonna, I guess, parse through it and try to find some more information about what's going on. So we have some questions that we need to answer, etc., etc. So instead of reading through all this, I'm just gonna start doing it, and then you can kind of follow along as I, type all this stuff out. So I'm gonna open this particular room in a new window on my second monitor. All right, so here we are, and let me zoom in a little bit better on this. Hopefully this will help us. Okay, here we go. So the command that we're using is rsyslog, and so we want to make sure first that it's actually installed. So we're going to run it with sudo, and we're going to do system ctl and status rsyslog just to see if this thing is installed. And it's going to take its quick little minute, but it says it's active, it's already running, and it gives us a few different events, so on and so forth. So I could just do end. Can I do escape? How do I get out of here? Quit. Control C. All right, here we go. Control C got us out of that. Okay, cool. So it's active and it's already running. Perfect. Now we're going to create a configuration file, and we're going to do a few different things right here. So it's a series of commands that I'm going to be running, and I'm going to try to make sure that I do this correctly, because copy pasting is not going to be an option right now. So let's try to make this work. Oh, I see. So you know what? There's various ways that we could have actually done this. So I used the very first command that showed up, which is the gedit command, which opens this up inside a new window, and then I can go ahead and type the configuration to this. But you could have done this with Nano, you could do it with the Vim editor, and so on and so forth. So there's a few different commands that they gave us. That was a little bit confusing. That's literally what was actually confusing me. So we have all of these commands right here, and so it's gedit and then Nano and then all this, and I thought that we had to actually apply all of them, but you don't have to apply all of them. You can literally just choose one. So whichever one your favorite editor is, you could do that. Gedit seems to be the one that I chose because it was the very first one, so that's going to be the one that I'm just going to use for this particular portion. So now what we got to do is we got to add the configuration, which is going to be a few lines of code. So let me zoom back in here so you can see what I am typing. But again, this is a free room, and you can go ahead and do this yourself and get access to it yourself. You probably already have access to this, so this isn't something that you are seeing, not seeing, but you know what I'm saying. Anyways, I'm gonna shut up and type this whole thing in so I don't make any mistakes. Okay, I think that's it. So now we're going to save this, and it's been saved, right? And then I can close it. So now I have that file. So it's going to be inside of the etc folder. So if I go to etc rsyslog.d, and let's do an ls command, and it's going to be 98 web server, etc, etc. So we're going to do cd 98 and take me there. Oh, I see. There's two of them. sshd. Oh, it's not a directory. Oh, yeah, of course, it's a configuration file that I made. Okay, never mind. I'm just acting stupid now. All right, cool. So we saved and closed the configuration file. All right. And let me pull this to the side a little bit here. And now we are going to restart syslog by applying the changes and running the whole thing. So we're going to do sudo. Okay, I think it worked because it doesn't give us any, we're not supposed to get any kind of a feedback or anything. So we're going to now verify the configuration by initiating an SSH connection to the local host via SSH localhost. Okay, I didn't have the password, but I think it also says you can literally check the log after a minute or two just to see if it's done anything else. But I've attempted to connect to the SSH of the local host, and I can see if I can find the information of this. Yeah, there's no username and password that is given to me for this particular device. So what's going to happen in this particular case is we're just going to do a Control C to end that. But even my attempt to try to log into the SSH should actually show up inside of that log file. So I'm going to wait a quick minute, and then I'm going to go check that log file and see if we got anything. All right, so here we go. Let's try this out and see what we get. So cat 98 web serve 02 sshd configuration. Oh no, I'm sorry, that's the configuration file. Gosh, I'm just making all the mistakes today. It's actually going to be inside of our variable log. location that we put inside of that code. So first we're going to go here, and inside of this we're going to have all of our actual log files. Very good. So now we want the one that we made, which is the rsyslog, and that's going to be the sshd.log. All right. And it says the question that we have is, after configuring the rsyslog for sshd, I'll show you here, what username repeatedly appears in the sshd logs at this location, indicating failed login attempts or brute forcing. So what we can do is we can grep for failed, because this seems to be a lot of information. Oh, there we go. Actually, you already see it right here. I could have grepped for it, but let me see. I just like zoomed by it. So what do I have? Failed password for invalid user Stan Simon. So failed password for invalid user Stan Simon. So let's see if it's Stan Simon. It is Stan Simon. Okay, so what is the IP address of sim02 based on the rsyslog configuration file etc rsyslog cron conf, which is used to monitor cron messages. So now we have to actually go to the other folder and find that specific one. So now I need to go back to the etc rsyslog.d, and we're going to look at the 99 webserv02 cron configuration file. Let's see what's inside this thing. So it says log forwarding with rsyslog file create 0644 program iSQL cron, so on and so forth, and the sim is 51514. That is going to be our answer. So 515. Oh no, I'm sorry, the IP address. Duh. The IP address is going to be this guy, 10.10.10.101. Cool. And based on the generated logs in this folder now, what command is being executed by the root user? So now let's go and try to find that one. So we need to go back into our var log. I'm going to try to grep for root and see if anything shows up here. Okay, so yeah, we got a few commands here. And the question says, what command is being executed by the root user? I mean, there's a few commands that are being executed by the root user. So I wonder which one we want in this particular case. So let's see. Okay, so it's mainly this command that I think is the important command. So the cd command may be the specific one, but I don't think it's that one. I think it's this command. That is it's kind of a more important command, because it's a bash command that they're running, and they're trying to execute this thing inside of our TCP connecting to this specific IP address on that port. I believe that is the command that we need to copy paste. So let's see if that's the one. Yep, that was the one. Okay, cool. So that was not that bad. Let me zoom out like that. Okay. All right. So we made some decent progress, and now we can move on to storage retention and deletion. Fun stuff. Making some decent progress. We're almost done with this room. All right, let's go check that out. All right, storage retention and deletion. So log storage, it can be stored in various locations, such as the local system that generates them, a centralized repository, or cloud-based storage. Depends on multiple factors like security requirements. They want to make sure that they're in compliance with organizational, regulatory, security protocols. Then you have accessibility needs, so how quickly and by whom do the logs need to be accessed. This also can affect obviously where you actually store them, storage capacity, so the volume of the logs that are generated, because you may have a really giant network. So you may need a lot of storage space, which will also affect your solution. Cost considerations, that one's kind of self-explanatory. Compliance regulations, there are specific compliance regulations depending on the health industry or banking or something like that. So there's always compliance to think about. Retention policies, the required retention time. So before you delete them and get rid of them, how long should you archive them for so that you can refer back? And of course, disaster recovery plan. So how many backups should you have? Should you have redundancies, contingencies, so on and so forth? So this is what you think about when you think about log storage. Now, log retention has to do with the types of storage, and it could either be hot storage, warm storage, or cold storage. And hot storage is logs from the past 3 to 6 months that are most accessible. And query speed should be near real time depending on the complexity of the query. Then as you get colder, the length of time gets bigger. And so, warm storages go from 6 months to 2 years, acting as a data lake, easily accessible but not as immediate. And then you have cold storage. It's been archived or compressed logs from 2 to 5 years, and these things are not easily accessible. They're usually on some kind of external storage, and they're just, kept inside a vault or something, or some kind of a secured environment. The cost of storing logs is critical for organizations, so making sure which one you've chosen or what kind of variation or combination you've chosen is also very important. Log deletion, kind of self-explanatory, but it's important to talk about. You got to delete logs carefully to avoid removing logs that should still be of value. The backup of log files, especially crucial ones, important ones, is necessary before you delete them. It's essential to have a well-defined deletion policy to ensure compliance with data protection laws and regulations. It helps to maintain a manageable size of logs for analysis, comply with privacy regulations such as the General Data Protection Regulation, which require unnecessary data to be deleted, and then keep storage costs in balance so you don't have to store things that you don't need and you don't have to pay for that. Best practices for storage deletion and retention. Determines the storage retention and deletion policy based on both business needs and legal requirements. Regularly review and update the guidelines for changing conditions and regulations. Automate the storage, retention, and deletion processes to ensure consistency and avoid human errors. Encrypt sensitive logs to protect data. Regular backups should be made, especially before you delete something. Practical activity is what we're going to go to, and this is for log management with log rotate. So we're going to create a configuration file. We're going to define log settings, which basically we got to type this whole thing in there, which I think I'm just going to copy paste because this is a lot of typing and I really don't want to make a mistake because then I would have to redo everything. And then save and close the file and then execute log rotate. So we are going to run this now. I'm going to go back to my little terminal here. And here we go. Alright, gedit was cool, so I'm just going to use gedit this time around as well, and we're going to create a new log here. Alright, here we go. We got our new window. By the way, like when you run that command, it takes maybe 20 seconds for it to actually load up. I chop all of that out for expediency, but don't be surprised if it actually takes some time for it to actually load. If you use gedit, you could do nano or any of the other ones and they'll be much quicker, but gedit is a little bit easier once it's actually open because you can click through it like this. Nano, you have to use the up and down and left and right keys on your keyboard. You can't click through it. So I copied the command. I have now pasted it in here. So we're just going to save gedit and we're going to close it. And now I'm going to run the sudo log rotate based on the file that we got. So that one should be very easy. There we go. So that's it. I mean, there's nothing else really that I got to do. But it seems that there is a file that we're saving all of this stuff to. So there is a text file that this configuration file is pointing everything to, which is going to be the verilog arsyslog sshd log, I believe. So based on log rotate configuration, the etc log rotate web server conf file, how many versions of old compressed log file copies will be kept. So the first thing to do is go to the etc log rotate.d directory and look at the configuration file that's in here, which is going to be our 198 cron file. Okay, very good. So we're going to do cat 98. Very good. And that is our, no, this is our SSHD. Gosh. Okay, cat 98. Oh man, I am today has been a tough day, you guys. I'm like making all kinds of mistakes. All right, so it's not 98, it's 99. Goodness gracious. All right, so cat 99 web server cron configuration file, and voila. So it says you're going to do it hourly, every 24 hours, I'm guessing. So it says how many versions of old compressed log files will be kept. So rotate, this is 24, sequence 1 to 24. I'm gonna say 24. So let's see. Well, I'm super zoomed in here. Let's see, 24. All right, cool, that's good. And based on the log rotate configuration, etc log rotate 99 configuration, what is the log rotation frequency? And this is going to be hourly. So let's see that. Very good. All right, cool. And last but not least is going to be hands-on exercise to log analysis, process tools, and techniques. So these are the stuff that we're going to be doing. And these are the log analysis tools that we got, etc., etc. All right, I'm not going to get ahead of myself. Let's do a quick little review before we jump into it. Alright, so as a quick review, log analysis involves parsing, normalization, sorting, classification, enrichment, correlation, visualization, and reporting. And you can do it with tools like Splunk and Elasticstack and really a lot of other stuff, and it could even be command line tools. So data sources, systems or applications configured to log system events. You have parsing, which is breaking down the log data into more manageable and understandable components. You have normalization, which is standardizing parsed data, and it involves bringing the various log data into a standard format, making comparing and analyzing data from different sources easier. Then you have sorting, which is a vital aspect of log analysis, and it allows for efficient data retrieval and identification of patterns. Classification involves assigning categories to the logs based on their characteristics. By classifying files, you can quickly filter and focus on those logs that matter most to your analysis. Enrichment adds context to logs to make them more meaningful and easier to analyze. It can involve adding information like geographical data, user details, threat intelligence, or even data from other sources that can provide a complete picture of the event. It makes logs more valuable, enabling analysts to make better decisions and more accurately respond to incidents. You have correlation, which involves linking related records and identifying connections between log entries. This is one of the big things that Splunk or Elk or these different things do, is they link related records. They link related records and identify connections between log entries from various logs. And it helps you get a big picture of what just happened, because good attackers will not be just doing one thing. They'll probably spread their activities in various locations using various applications and strategies. And by looking at just one log file, you're not going to get the full picture. So correlation is very important. Visualization is the part where you don't have to read through lines of log data, and you can just look at a dashboard like this thing right here, and it makes it so much more manageable when you see graphs and pie charts and just a bunch of different things that make it so much easier to read. And of course, reporting, which is just creating reports, creating PDF reports and things like that. And Splunk does that magnificently. Elk does that magnificently. Like, the reports that come out are really, really dope reports, and all the graphs and all the data is all embedded in it. So reporting is really, really important. So SIM tools, security information and event management, such as Splunk or Elastic, can be used for complex log analysis. However, in scenarios where immediate data analysis is needed, such as during incident response, Linux-based systems can employ default tools like cat, grep, sed, sort, unique, awk, along with the SHA-256 sum for hashing log files. Windows-based systems can utilize easy tools and the default commandlet, which is get file hash, for similar purposes. These tools enable rapid parsing and analyzing, which suits these situations. Additionally, proper acquisition should be observed by taking the log files hashed during collection to make sure that admissibility in a court of law is very, very important, and chain of custody is done, so on and so forth. So it's imperative not to only log events, but also ensure their integrity so that they can be analyzed and taken through the chain of custody process. We have log analysis techniques. So pattern recognition involves identifying recurring sequences or trends in log data. It can detect regular system behavior. Anomaly detection focuses on identifying data points that deviate from the expected pattern and is crucial to spot potential issues or malicious activities. You have correlation analysis, correlating different log entries. That helps us understand the relationship between various events, and it can reveal causation and dependencies between system components, and it's very vital to finding the root cause. Timeline analysis, so analyzing logs over time, helps to understand trends, seasonalities, and periodic behaviors, and it's important for monitoring and forecasting. Machine learning and AI, very super freaking useful. Leveraging machine learning models can automate and enhance various log analysis techniques, such as classification and enrichment. AI can provide predictive insights and help in automating response. And I mean, it's so powerful. You can literally drag and drop a file inside of ChatGPT right now, and it'll analyze the file for you, and it'll tell you what's going on. So you don't even need to copy paste anymore. You literally just drop the log file in there, and it could do some amazing things. And if you know how to work with API, you can connect the API of these various AIs to the API of Splunk, for example, and now you have both of those things. It's super, super freaking cool. Visualization, representing log data through graphs and charts, etc. Statistical analysis, using statistical methods to analyze log data that can provide quantitative insights and help make data-driven decisions. Regression analysis and hypothesis testing can infer relationships and validate assumptions. These techniques can be applied individually or in combination depending on the specific requirements. So, working with logs. Here we go. This is what we're going to be doing. And unparsed log files is, oh my god, look at how this looks so intimidating to me. I hate stuff like this. I really can't stand stuff like this. Like, even though I'm pretty good at using command line, I have to use things like grep and these various tools to make sense of this kind of stuff, because this is just intimidating. So what are we gonna do? We are going to paste this URL into your browser to view the unparsed raw files using the log viewer tool, and then you can access it using the attack box or the VM browser. However, please be aware that Firefox on the VM may take a few minutes to boot up. Okay, I should have started the attack box earlier. Parsed and consolidated log file. We're going to create a consolidated log file using a combination of tools like so, and this is a step-by-step using awk and sed to normalize the log entries to the desired format, and we're going to sort by date and time, and these are going to be the various commands. Look at this. This is all intimidating, isn't it? To me it is. This is like, oosh, what's happening? Then you're going to use grep to filter specific entries, or that's an optional, and then use sort, use the unique, and now you can access the parsed and consolidated log file through the log viewer tool using this URL. and you can access the log using the attack box or VM browser. So I'm just gonna use the attack box, or not the attack box, the VM browser. It might take a minute to load up, or not. It seems like it's working quickly, but we will go ahead and make this work. We're gonna make it happen, and we're gonna get the information to answer these questions. All right, that wasn't that bad. We actually have 2 questions that we can answer real quick. So one of them is, what is the process of standardizing parsed data into more easily readable and queryable formats? And then what is the process of consolidating normalized logs? So if we go up here, and first and foremost, we're going to look for standardizing. So this is normalization. Standardizing parsed data is normalization, and then consolidating normalized data is the other one. So let's see which one that is. Okay, so normalization would be this one. Consolidating normalized logs to enhance the analysis of activities related to a specific IP address. Okay, the keyword in this is going to be enhance the analysis of activities. So the only thing that I found right here that was kind of close to that is enrichment. That it adds context to logs and makes them more meaningful and easier to analyze. It would involve adding information, yada yada yada, that can provide a complete picture of the event. It makes logs more valuable. So I think this is what it is. I think enrichment is the answer we're looking for here. All right, cool. Enrichment is it. And now I can actually go inside of my browser and go and look at what it says, unparsed raw log files. So what we want to do is we want to look at it with this link right here. So we're going to copy this and we're going to paste this inside of our browser and go and look at that. All right, it's loading, but I think we can actually just, oh, there we go. It's fully loading. The question is asking what happens, what error does this thing show when selecting different filters? So what we need to do, okay, so the answer is actually back where all the 4 logs were listed, and we didn't need to click on the specific cron log directly. It's this piece right here, the no date field. And you don't need to select a filter or anything like this. And the way that you find that out is when you go to the hint, it says click on the drop down button beside add filter. That's what it says right here. So if I actually go here and click on this drop down button, it gives me the error inside of all of these. So it's no date field is the error that I believe is our answer. Yep, that's it. So there we go. Finished this particular room. This was cool. It's labeled as a hard pathway. So the SOC Level 2 pathway, I'm going to terminate this machine because we're done with it. The SOC Level 2 pathway, when you click on it and when you go to this thing, it's labeled as a hard pathway, as a difficult pathway. And this is kind of I'm trying to find the freaking button here to show you that stuff. I think it's inside of learn or whatever, but that didn't seem too bad. That's basically the point that I'm trying to get to right here. There we go. That's where it says hard. That didn't seem too bad. Although I'm just going to take their word for it because that was literally the very first room, the very first day, the very first room. So that was it for our intro to logs on the SOC Level 2 pathway under log analysis. So this should be fun. I will definitely see you in the next one. All right, if you got value from this video, if you like this channel, or if you just want to show support and join our community, I very much encourage that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And to make it extra sweet for you, because if all the content wasn't enough, I'm going to be revealing my identity once we hit 100,000. And I feel like we're going to get there fairly quickly, or relatively quickly compared to other channels and things like that. But there's a lot of good videos on here. There's a lot of good content. Almost everything that we talk about in our channel has some kind of reference video that's already in the videos that I've uploaded, so you can just learn more from it over there. And it would just be really awesome to have you as a part of the community. We get a lot of comments coming in. I respond to all of the comments, and I sometimes even create videos for the comments that do come in. So we'd love to have you in the community. We'd love to hear from you. So make sure that you like, subscribe, and turn on that notification bell. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Oh, by the way, this is the new logo. I don't know if you guys noticed, but that's the little Linux penguin. So I'm really I'm excited about that one. Yeah, love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next video later. All right, hello and welcome to episode 2 of the SOC Level 2 pathway that we are on right now. Today's episode, we're going to be going through the log analysis module and the log operations path, I guess specifically, or the log operations room. And this is literally just going to be a continuation from the last video that we did, and it's more so a read type of a video. It's more so an informative type of video. There are no labs, as far as I can see, that have been attached to this, so it should be fairly easy. You can probably put this on 1.5 speed or something like that, although I do talk fast when I read through these things just to make it a little bit more interesting and not as boring. But that is essentially the kind of the path that we have ahead of us right now. This is one of the free rooms that's available on TryHackMe, so I would encourage everybody, if you don't already have a TryHackMe membership, to actually go through it. There's a link in the description below, and set yourself up for at least the free membership, because even with the free membership, there are some rooms that allow you to start virtual machines and the attack boxes, and really just kind of get some lab experience under your belt, some real live experience under your belt, and that's always valuable. So that is it for our specific intro to this video. Now let's just jump into the introduction of this particular room. Okay, so log operations are really just trying to find something inside of a log, especially if it's a really big network or if it's a really busy machine or something like that you're really looking at, a busy endpoint that you're looking at. It's very similar to looking for a needle in a haystack. This is one of those types of experiences that it can be very overwhelming if you're just looking at a raw log file, as you kind of saw that we did in the last video. A raw log file is just literally lines and lines and lines of text, and if you're not using anything like Splunk or ElkStack or anything like that, it just becomes overwhelming, even for the person who's really good at this and they know exactly what they're looking for. It just becomes super overwhelming very quickly. So if you don't know how to use different command line tools, or if you don't know how to use various visual emulator tools, it's going to be a difficult experience for you. So if you're talking about an incident investigation, if you get lost in the log space watching and just wasting time, it's going to be a bad thing very quickly, because incident response requires quick response to things. Otherwise, the incident just continues to get out of hand. So what we're going to be talking about in this particular room is the configuration approaches required to manage and analyze logs in an operational context. And the log information that we learned in the previous room is going to be a kind of like a piggyback off of that room. The objectives are to understand the logic of log management and configuration, familiarize with log configuration approaches, experience the log configuration process, and these are some of our prerequisites. So you got to understand what Microsoft Windows looks like, you got to understand what Linux looks like, and the working knowledge of network and endpoint log systems, and of course the intro to logs, which we did in the last video. So if you haven't seen the last video, I would recommend you go watch that video. It's going to be episode 1 of this SOC Level 2 series. And yeah, those are just some of the prerequisites for this, and this is the basic introduction. So without further ado, let's actually jump into the first official task here, which is configuring logs, so log configuration. Okay, the first line is very much in line with exactly what I was trying to say earlier. It goes, do you dare to configure your logs, or are you happy to be lost in the madness of the thousands of lines. And I don't know where this is from, but this is pretty apt as to what really goes on when you're looking at a log file. And kind of the spirit of this entire task is to sell you on the idea of why you should configure your logs to just make it a little bit easier to decipher and approach the whole thing, right? There are multiple concerns about configuration approaches, and identifying the suitable configuration approach could be a pain point, meaning it could be a difficulty for a person, a company, a team, and this is hopefully this is something that you'll at least have some more understanding of, and then you can take some value into whatever meetings you go to for your SOC teams and things like that. So log configuration is a multifaceted operation that addresses the security, operational stability, regulatory compliance, and debugging needs. Adequately configured logs are crucial in cybersecurity, operational efficiency, and regulatory compliance in software development, providing organizations, yada, yada, yada. So this is, I mean, if you wanted to, you could just go read through this directly yourself. But the big points, the main points here are these pieces right here. So these are the goals that we have in mind, or these are the solutions, the problems that we're trying to solve for when you talk about log configuration. So logging and configuration for security purposes are typically planned to detect and respond to anomalies and security issues, okay? For example, configuration to verify the authenticity of a user activity to ensure authorization control and timely detection of unauthorized access. Anomaly and threat detection, logging user authentication data, and ensuring the system's integrity and data confidentiality. These are the goals for the security approach for log configuration. You want to configure your approach to detect anomalies and threats. You want to configure your approach to log user authentication. So, you know, login attempts, incorrect passwords, the number of repeated incorrect login attempts, and then once they're actually in, the ensuring the authorization control part of it. So what do they have authorization over, and is somebody accessing something that they don't have authorization on, and how did they get that authorization, so on and so forth. So that's a really big concept. And then of course ensuring the system's integrity and data confidentiality, and that one's kind of self-explanatory. System integrity means that the system should be up and running. There shouldn't be anything that affects the capacity of the system to run. It should have solid processing power, solid integrity. There shouldn't be anything that's been tampered with. And data confidentiality is you just don't want to lose data. You don't want to have data be exfiltrated. You don't want data to be accidentally deleted or lost or stolen, any of those things. So the next one is operational purposes. And operational purposes configured to things like planning to detect and respond to a system error and identify action points to enhance the system's performance, continuity, and reliability. The main focus areas here are proactively creating reports and notifications for on-system and component status, troubleshooting, capacity planning, and service billing. So proactively creating reports and notifications for on-system and component status. So the system status or any components of that system, troubleshooting if there's any kind of error or any kind of bad service running, capacity planning. So how much capacity does something have? How much can it handle? Do we need to increase the capacity? Should we lower the capacity because we're not using as much of this? And then how do we bill it, right? So billing for that service and handling the billing of that service. Then you have legal purposes. This is a big one. I mean, legal purposes, compliance, regulations, all of these things. This is a really big deal when it comes down to any kind of business that's in information. And specifically, these are some of the standards that you're going to run across that are very, very common standards. So ISO 27001 has to do with just general operations of, and I'll actually even Google this for you so you can kind of get a good understanding of it. So it has to do, it's an international standard to manage information security, and it's kind of the general standard to manage information security, and it was originally published and jointly by the International Organization for Standardization. I guess it should be iOS, but I think it's ISO, and then IEC is the International Electrotechnical Commission. So this was originally published in 2005, revised in 2013, and again in 2022. And this is basically the standard to manage information security. That's what ISO 27001 and 27002, they both fall under this kind of like a general approach to information security. Then you have COBIT, and then you have the General Data Protection Regulation, then you have the Payment Card Industry Data Security Standard, then you have HIPAA for Health Information Portability Accountability. So any kind of, this could be an insurance company, it could be a hospital, private practice, anything that has to do with somebody's health history and their health planning, all of that stuff falls under health. HIPAA, and then FISMA is a federal regulation. So the Federal Information Security Modernization Act, when I was working for AT&T and I was doing consulting and we were setting up the IoT devices and the networks for fire stations, we had to abide by the FISMA regulations. They actually got their own set of satellites. They didn't even use the satellites that were connected to like the general consumer public. So FISMA is a big one, HIPAA is a big one, PCI is a big one, GDPR is based, it was originally founded in Europe, but if you have a website that sells to anybody in Europe, you immediately have to comply with GDPR, ISO 27001, and then COBIT, I just want to make sure that I have a good understanding. It's the Control Objectives for Information and Related Technologies. It was created by ISACA to bridge the crucial gap between technical issues, business risk, and control requirements. So this is a control objective, and the COBIT framework was created by ISACA to bridge the gap between technical issues, business risks, and control requirements. So that is what COBIT is. And now we finally we have a little example here actually. So for legal compliance, a company must have an active central log management system, adequate log configuration, 12-month log retention logs for affiliate system, and then of course system and component security checks and overall yearly audit checks to meet PCI logging compliance. So just for PCI, so for payment card industry, if you're collecting any kind of payment card information, just for that, these are the, I mean, these are even general. I don't think this is specific to all of the things that you have to do for PCI, but just for PCI, these are the things that you would have to do to maintain compliance with legal purposes. And then of course we have debugging purposes. So logging and configuring for debug purposes is to boost the system's reliability and enhance provided features by discovering the bugs and potential fault conditions. This configuration scope is not always implemented in the production environment and is mostly used for testing and developing purposes. The main focus areas of this approach are increasing visibility for the application debugging, enhancing efficiency, and speeding up the development process. So this was specifically, this has to do with some kind of an application or some kind of a website or some kind of a product that's being released specifically with information security or cybersecurity, and you need to make sure that you debug the web app and make sure that it runs smoothly. That's why they have beta launches, and there's a lot of different variations how to make sure that debugging is done properly. We did multiple videos on the software development lifecycle and the security of the software development lifecycle, so you can search for SSDLC and you'll find those videos on this channel. And if you can do debugging in your development process, meaning while you're coding and creating the thing, that's amazing. But usually debugging is done after you've actually launched, or at least launched in the beta level, so you can test to see if everything is running smoothly, and then you do some runtime tests to make sure that there's nothing to debug, but there's always something to debug. So you just want to debug before you fully go public, and then after that you want to constantly debug. So when Microsoft releases a new version of Microsoft, that means they've worked through certain bugs or they've worked through certain security vulnerabilities that somebody has discovered, like a pen testing team has discovered, and now they need to debug for that, and they need to fix that, they need to patch that. That is a version of debugging. It's not necessarily a bug that prevents it from running, but it could be something that could be counted as a vulnerability that you need to patch. So that all falls under this specific bullet. So we got a couple of questions here. It says, which of the given log purposes would be suitable to measure the cost of using a service? And that was the second one, which is operational purposes. So we're going to type that in here. and that should be good. And then which of the given log purposes would be suitable for investigating application logs for enhancement and stability? And let's see, I think application logs would probably also be under operational, but it doesn't seem like it. I'm gonna say debug. I think it's debug. Yeah, there we go. All right, good stuff. Now let's move on to the next one, which is where to start after deciding the logging purpose. All right, when you figured out what the log purpose is, what do you do, right? What's the next thing that you got to do? If you already have the objective and scope plan, but you need help knowing how and where to start, you can use the meeting and brainstorming with your team. If you don't, then you need to figure out the objective and scope plan, which kind of goes back to the last one. Each log configuration is planned and implemented to fulfill a different goal, right? So there's the ones that we just talked about, they adhere to different goals, right? There's the security one, there's the operational one, there's debugging. Questioning is one of the most common ways to identify the needs. It's very, very basic. So this is where like the team dynamic comes in and team meetings come in. And these are just some general questions. I feel like these questions can be probed further, right? But this is a good place to start. So what will you log and for what asset scope or logging purpose? And is additional commitment or effort required to achieve that purpose? So are there requirements related to the purpose? How much are you going to log, right? So how deep do you want to go with the log? This one is talking about what is the asset scope, which means how many endpoints, how many machines, how many networks, offices, how wide are we going with this logging? And then this one is how much detail are we going to get from each endpoint? How deep do you want to go with the logging effort? And then how much do you actually need to log? Like how, I'm guessing this one is like how far do you want to go, or it could be kind of like a piggyback off of this thing. How are you going to log? So what's going to be our collection method? Are we going to do it through the command line and collect all the files per computer? Are we going to do it using a SIM or some kind of a centralized tool? And then how are you going to store the collected logs, standard, process, legislation, or law that you have to comply with due to the data that you're actually logging? The storage of the collected log. These are the things that we actually talked about in the last video, so you'll probably get a good idea of that if you have already watched that. How are you going to protect the logs? Encryption, passwords. What are we doing to protect these logs? How are you going to analyze the collected logs? Are you going to do it manually? Are you going to have a team do it? Are you going to set up AI to do it? Are you going to use a pre-configured tool like Elasticstack or Splunk to do it? What are you going to do? Do you have enough resources and workforce to do logging? Believe it or not, it takes a lot of storage. It takes money to just store logs and collect logs. It doesn't seem like it, but it can get overwhelming very quickly. You can get a lot of data really quickly depending on the size of the company. Imagine a company like Amazon that has, thousands of employees and probably thousands of computers that are assigned to these employees, and each one of those computers is generating a number of logs, probably at least half a dozen logs per computer, and then each one of those logs has thousands of items in it, and you have to store all of this. And so do you have the resources to do these kinds of things? And then do you have enough budget to plan, implement, and maintain logging, right? So these are just general questions, but then you can probably just go deeper and deeper and probe further when you're addressing this specific field about actually what are you going to do after you have the purpose of your logs, right? So the question for here is, you're a consultant working for a growing startup. As a consultant, you participate in a log configuration planning session. The company you work for is working to get compliant to process payment information. To give the question, the given question set is being discussed. Which questions answer can be as much as mentioned in the PCI DSS requirements. So which questions answer? So this is the answer they've given us, and the question that we're trying to talk about is how are you going to store the logs? Probably that would be one thing that I would think about. Let me see. As much as mentioned, probably this one actually. How much do you need to log would be as much as mentioned in the PCI DSS requirement? So I think that's the question right here. So let's copy this question and put this right here. Let's see if that's it. Yep, that's it. So how much do you need to log? As much as mentioned in the PCI DSS requirements. How much wood would a woodchuck chuck if a woodchuck could chuck wood? As much wood as a woodchuck could chuck if a woodchuck could chuck wood. That's basically that flow of questioning. How much do you want to log? As much as they are telling us to log, right? That's basically it. All right, so moving now into a little bit of a scenario here. So you have a configuration dilemma. So let's read through this and try to find out how we're going to address this. Configuration dilemma reflects the challenges of implementation. As highlighted in the previous task, each log configuration scope comes with responsibilities, guidelines, and challenges. This means that the log configuration and logging are more than a simple practice of enabling logging from the assets and surviving among thousands of lines. So each log configuration plan results from a unique analysis of the scope, assets, objectives, requirements, and expectations to be applied. Expectations, requirements, and limits are determined with the involvement of system administrators, legal and financial advisors, and managers, if possible. In summary, the main source of the dilemma is finding the balance between requirements, scope, details, and price, which means price can break down into a few things, right? So it could be financial and labor costs. It could be the risk that you're taking and the investment that you're making. So all of those things can fall under price. And during the meeting, there might be some points where participants get off point, but it's vital to keep in mind that the main objective of the meeting is to meet specific operational and security requirements, which is non-negotiable, so you have to meet these, and then while also considering the feasibility of improving the capability by implementing additional data and insights. And last but not least, a comprehensive risk assessment, prioritizing security, compliance, and legal needs will be helpful to navigate this dilemma, finding the balance in operational and management level decisions and achieve secure, efficient, proactive, resilient, and sustainable outcomes in ever-evolving threat. It's so long-winded. It's so crazy. Okay, but you get it. I feel like you get it. So translating the requirements and aspirations to operational level, right? So you have requirements and aspirations that are being handed down to you by your C-suite executives, by the management team, and you need to actually translate that into an operational level, meaning make it practical, right? So how could we actually make these requirements work, right? So the dilemma started like this. So the base requirements were these, and then the aspirations for better insights were these. So what happened? When did it happen? With time, if possible. Where did it happen? Who and what caused this thing to occur? Let me zoom in a little bit. And then from which log source? And then the aspiration is it possible to get more data from this? Can we get more details? How sure can I be that this is actually true? What is affected? What will happen next? Is there anything else that requires attention? And what should I do about the incident? So these are the things that you should definitely be able to answer. So what happened? This happened. When did it happen? At this time. Where did it happen? On what network, on what system, so on and so forth. Who was it that caused it to occur, and what was the log source? All of these things is black and white, right? It's like you can easily answer these questions. These are the questions that are aspirations, right? So is it possible to get more data? Can we find out more details about what happened? How sure can I be that this actually happened? What was affected? So whatever they did, how did it affect the network? How did it affect the system? What's going to happen next? What do you think these people are about to do again? Or what do you think they're going to continue to do? Is there anything else that requires attention that maybe you missed? Or that maybe in all of the activities that they did, was there something that went further down the rabbit hole that you can try to find that maybe other systems are now compromised? And what do we need to do to either prevent this from happening again, to stop this in its tracks? You know what I mean? So these are all the things that aren't black and white. This is not information that you'll find exactly in a log. This is information that's done through investigation. This information you get from the log, right? This information is through investigation and through speculation and connecting dots and things like that. So while the main focus is the same, two question sets represent two distinct dimensions of logging and analysis. The base part heavily relies on an incident detection mindset, It provides a solid framework for logging and analysis, but it's reactive. The requirements are a good place to start, but primarily helpful against known threats. The aspiration is more focused on threat hunting, investigative, right? Threat hunting. Therefore, it's proactive and it requires more resources due to the need to go above and beyond. Therefore, this part is more helpful against advanced and sophisticated threats, which is what's going to most likely happen if you work for a large company or if you work for the United States government or the government of your specific country. That usually an attack that's done against a country or a big company is not a weak attack. It's not some idiot that doesn't know what the hell they're doing. It's somebody that is well read. They probably work in a team and they probably have resources, like somebody's financing their activities, so they can do some advanced and sophisticated stuff. So the baseline part is necessary for a solid incident detection and response scope foundation. However, adopting proactive aspirations by adding them to the operational vision is strongly recommended given the ever-evolving threat landscape. So the session continues. So this means that your meeting has continued and your teammates need your help. They will negotiate for logging budget and operation details. As a consultant, you must remind them of a vital point, which requirements are non-negotiable, right? And so we have them right at the top right here. These are our non-negotiables. Operational and security requirements are non-negotiable. And that is going to be our answer. So that was it. Now let's move on to the next one, principles and difficulties. Okay, so now we have to address some of the difficulties that show up and the principles that will ideally solve those difficulties, or at least give you some kind of a guideline to approach those difficulties. Logging is obviously very important, and it's a process that is as burdensome as functional, right? So it's functional and it's helpful and it's useful, but it's also a big ass burden that you need to take care of. And it requires active resource utilization, meaning you need to constantly be thinking about the resources that you're using to log and to analyze logs, right? So it's crucial to implement a proper logging operation and ensure that its effectiveness and efficiency are high, right? There are multiple principles which help achieve this. So here we go. Let me zoom in a little bit more here. So collection. Define the logging purpose. Collect what you will need and use. Do not collect irrelevant data. Avoid log noise, right? So this is the principles for collection. You want to have a purpose for what you're doing. Only collect what you actually need. Don't collect irrelevant data because it takes up space and it takes up memory and it takes up money. And avoid log noise, because log noise, when you're trying to do incident response, you have to sift and sort through a lot of data to try to find what you're looking for. And if you just have useless noise inside the logs, then it's going to literally kill so much time and energy and money. Then you have the log format. And we discussed this actually in the last video. There are various types of formats for logs. It could be anything from an application log or a web server log, or it could be an unstructured log or a structured log. So those are the things that you want to be considering, and this is the philosophy that supports that. So log at the correct level and detail, implement a consistent format, and ensure that the timestamps in logs are accurate and synchronized. The synchronized part is really important so that all members of a team can know what's going on. Usually it's UTC, the universal time, that kind of applies to everybody, because depending on like what geolocation your team is, because some people are working remotely and things like that, it's always good to use UTC so that people can just convert UTC to their individual time. And then of course the timestamps need to actually be present. So that's the part that's like, if you don't have timestamps or if you haven't chosen to have timestamps, it's going to be very difficult to do incident response. Archiving and accessibility, we talked about cold storage, warm storage, and hot storage. So you need to establish that. So log retention policies and implementing those, storing log data and make sure that the important part is available for analysis, create backups to have access to whenever you need to, redundancies just in case something gets deleted and you actually need that information. Then you have monitoring and alerting, and this is usually what SIM software is used for. Splunk and Elasticstack, they help with monitoring and alerting, and they'll create alerts and notifications for important and noteworthy cases. Usually they do that for you, and then the more that you use them and the more that you adjust them, the baseline of those alerts become even more specific and more useful, because sometimes they might alert you into something that's a false positive and it's going to waste time. Sometimes they might miss something that would be a false, and it's considered a false negative, and you have to go and find it yourself manually. So focus on actionable alerts and avoid noise. Again, notice how this has been mentioned again: avoid noise here and avoid noise here. This is an important concept because logs can get very, very busy, and they can get a lot of items inside of a log, and you want to focus on things that are actually applicable and actionable to what you're doing and what you're looking for. Security, a really big one. Who would have thunk it? Protect logs by implementing access controls, implement encryption if required, and use a dedicated log management solution. And these two, this and this, kind of go hand in hand here. And then you have continuous change. So logging sources, types, and messages are constantly changing and being updated. So be open to continuous change and train your personnel. This is something that needs to be done regularly, especially with the security team. So it should be done with regular, average Joes, so to speak, average Joes and Janes. It should be done with everybody, but the security team, the people that are involved in the security team, need to be continuously trained, and any new thing that happens, everybody needs to know about so that they're aware of it. Then these are our challenges. So these were our philosophies, and these are the challenges that you're going to hit. And so the very first one is data volume and noise, and we addressed that twice in our principles, right? So it's like having multiple data sources to deal with can give you a lot of volume. We already talked about that. Differences in the log volumes create by application. Some applications generate an insufficient amount of logs, and large scale applicants could generate massive log volumes, which leads to noise. And some logs can provide non-essential data and make the identifying process even more difficult. So the volume of data can work in both ways. You could have too little of data, too little of volume, or you could have too much volume. And they both represent different types of problems when you actually get to incident response, right? So if you don't have enough volume, if you don't have enough data, you're going to have a problem connecting the dots. If you have too much data, you're going to spend too much time and energy trying to sort through the data to find the information that you actually need. Then you have system performance and collection. So log collection can slow down the system's performance because it's taking up the processing power. It's taking up RAM on the computer, right? Systems are not always state of the art. That's very important. Legacy systems, because the company is using some kind of a software that is only available for a legacy system, those systems are slow. They don't have enough RAM, and they don't have a strong enough CPU. So they'll take a lot, they'll become super slow just because they're logging, right? Some sensitive or ancient systems are impossible to touch. That's a really funny way to phrase it, but yeah, basically. And in deployment and optimization challenges, managing system and agent version updates and synchronization in large-scale networks is overwhelming. Keyword here is large-scale networks. So managing the applications and versions of the systems and just updating them and patching them, synchronizing them is overwhelming in a large-scale network. It's very different to synchronize a network of 10 devices versus a network of 10,000 devices, and that's very important to understand. Then you have processing and archiving. Having multiple data formats to deal with, parsing different data sources and formats is time-consuming and error-prone, and then balancing the log retention can be challenging, especially when dealing with many compliance regulations and standards. So ensuring data security is a task challenge in itself. That's the piece right there. That's a challenge just by itself. Then you have the analysis, combining, correlating, and analyzing data from multiple sources to understand what just happened in an incident is time-consuming, especially if you don't use a tool, and it requires significant computing resources and expertise. So doing this in real time, meaning live, is also another challenge in the same scope. Avoiding false positives and negatives is overwhelming. So all of this stuff falls under analysis, and usually that can be done with Elasticstack or Splunk or any kind of I think QRadar is another one. There's so many of them. There's so many security information and event managers, and they're all very, very powerful, and they're all super useful. It just depends on what your company, what they can spend on, and what they prefer. But overall, you want to have some kind of a tool doing your analysis for you instead of somebody sitting there manually doing it. You don't have the tool replace the person, because the person can catch things that the tool misses, which is why you have these false negatives and false positives conversation. But the tool is usually very helpful to to quicken the process, right? Then there's miscellaneous things. So lack of planning or a roadmap, lack of financial resources or your budget, lack of implementation scenarios, playbooks, and exercises. This is a big one because this has to do with the human element. This has to do with people not being trained and not being rehearsed enough to respond quickly and not buckle under pressure. Lack of technical skills to implement, maintain, and analyze, focusing on log collection instead of the analysis phase, ignoring human factors and potential system errors. These are all miscellaneous. These are all challenges, and I don't think this is even the full list of challenges. This is just the important stuff that has come up so constantly that you need to be aware of, and then you can work from there. So these are common and can vary according to your case. However, the main point is adhering to logging principles and proactively addressing challenges. So going back to our scenario, your team is working on policies to decide which logs will be stored and which portion will be available for analysis. Which of the given logging principles would be implemented and improved? So we're talking about storage, right? And what's going to be available for analysis. And this is, I think, the archiving process. So right here, process and archive. Is that what they're asking for? Which of the logging principles? So we need to actually go to the principles right here. So it would be archiving and accessibility, I would say. So let's see. There we go. And your team implemented a brand new API logging product. One of the team members has been tasked with collecting the logs generated by the new product. The team member reported continuous errors when transferring the logs to review platform. In this case, which of the given difficulties has occurred? So continuous errors were when transferring the logs to the review platform. I'm going to go ahead and say that this is under process and archive. So I think that's probably what that is. Let's see. Yep, that is it. So there we go. Now we're going to move on to the very next piece right here, which is common mistakes and best practices. And just like that, we'll be done. This was actually, I think, a quick video. So let's get into this one and wrap it up. Alright, there's no doubt that logging is powerful and valuable, but maximizing this power and actually using it takes a lot of planning and implementation. You can't just do it willy-nilly because of literally all of the challenges that we discussed already. So if you don't do it, then logging will become inefficient and it makes things even harder. This says difficult. I think it makes them even harder. It makes it tedious. And it drains resources, and resources could be time, energy, and money. It just doesn't have to be money. So in addition to the high and low level details, strategies, and suggestions discussed until this point, a few more things require your attention. It's continuous and a live operation, which means it needs continuous maintenance and improvement. So the infamous "if it works, don't touch it" approach is not acceptable in this particular case, because you don't know if it's really working and if it's doing exactly what you want it to do unless you are so fine-tuned and so optimized. But even at that case, things get updated and the logging tools that you're using get updated, the system OS gets updated. There are so many things that you have to just constantly be aware of. There's no such thing as, set it and forget it in this particular case. In this environment, there is no set it and forget it type of an approach. So the threats and computing technologies evolve. Therefore, you must update your configurations and adapt the changes accordingly. Implementing the following actions is a good place to start, and self-assessment. So learn from mistakes and failures, track the sectoral threat dynamics for the operated sector, and conduct regular scope and resilience testing. Follow the best practices of industry leaders. And this is kind of a nice way to look at this. When you want to think about reconfiguring or updating the existing configuration, these are real life experiences, right? So The experience in this particular case has been a log analysis nightmare due to improper log configurations and or lack of configuration. So this was what happened. There was a nightmare, log analysis nightmare, due to improper configuration or lack of configuration. The storyline is this: there was a Microsoft Windows 7 operation system, and it was on a default logging configuration, and it provided 0 or insufficient logs when the system was compromised with Eternal Blue vulnerability. And in our pen test videos, we used this Eternal Blue vulnerability a lot, and we used Metasploit to do it. So this is applicable to Microsoft Windows 7. So there's a lot of ways that you can find. Shodan.io is like one of these really great websites where you can go and search for devices across the world with Microsoft Windows 7 operating systems, and then you can just get Metasploit from Kali Linux and implement the compromise against that machine and exploit the machine, which is really scary to think about. No significant event logs were created under the system security and application logs, right? So that's what happened. The damage, so this is the attack details. So the damage was full access to the victim system, because Eternal Blue literally lets you get a shell inside of the system. And then once you have the shell, you could do anything. You could transfer files, you can access their email, you can steal data, anything, right? The impact was high, and the score was 8.1 on the CVSS score, the Common Vulnerability Scoring System. It was 8.1. And the note was that Windows 7 SP1's official support date ended in 2020, and the exploit was discovered and used in the world, in the wild, in 2017. So this is fairly recent. This is not back in the beginning of time, right? This is a relatively recent experience that had happened. And the big thing here is that the operating system, so the Windows 7 OS, had default logging operations that provided 0 or insufficient logs when the system was compromised with that specific vulnerability and exploit. So the common mistakes and the best practices to address those mistakes. So it says logging sensitive information, and so I guess I'll go through all the don'ts, right? So logging sensitive information, don't do it. Creating logs by yourself, don't do it. Having uncollected logs, collecting everything but not analyzing, collecting logs without proper planning and configuration, having systems that lack the planned or required log configuration, skipping the scale testing and functionality analysis, focusing on edges, and skipping the internal systems in analysis. This is an interesting thing to think about. Edges is referring to the surface level, and skipping the internal systems, meaning the deeper that you go inside of the network, or the surface levels of the OS or the computer, and skipping all of the deep-rooted stuff like maybe the kernel or something, right? Searching for what you want to find and not investigating what you actually see. Don't do that. Forgetting that the processes take the form of proper planning, management, and analysis. So these are the things that you don't want to do, right? So let's go to our do's. Let's go. This is what you do want to do. Do this. Create a suitable log configuration and plan according to your system. Implement testing on scale, functionality, and operational stability. Exclude logging sensitive information. See, do exclude logging sensitive information. Don't log sensitive information. You see how that showed up twice? Secure your logs. Encrypt them. Put them in a place where it's password protected. Create meaningful alerts and notifications. Focus on having insights on actionable and impactful results. Train your analysts and enhance their skills. Update and maintain your operation plans and components assets as needed. So, last question. As a consultant, you are doing a comprehensive risk assessment and notice that one of the development teams implemented a custom script to generate logs for an old system, which omits logging at some phases. What would you call this? Is this a mistake or practice? That's a mistake, because he created a custom. So where is it? It's right here. Creating logs by yourself. He created something to custom collect information, and it omits logging in some phases, right? So it's an old system already, it's omitting logs in some phases, and it's custom made, meaning the guy made it himself. That is definitely a mistake. So there we go, that's what we got. And just like that, we have now wrapped our log operations room. So congratulations for finishing this. The next one is going to be log universe, I think. Proceed to the log universe room. Is that a part of our SOC level 2? It's not. It's actually a completely different one. So you know what? I think I'll probably do this, but what's going to happen is that it's not going to be a part of the SOC level 2 pathway. So I'm not going to include it as the SOC level 2 pathway, but I'll kind of do like a we'll do a episode 2A kind of a thing, where we're just doing a continuation of this specific room, and we're just going to do the log universe room as a result of that. So that'll be the next video that'll come after this, or maybe I'll just drop them both on the same day. I might just drop both of them on the same day, or maybe during the same week. I don't know. I'm trying to establish a more consistent posting schedule, so we'll see how that part goes. But right after this recording, I'm just going to record the log universe room, and then we'll proceed to episode 3, which is intro to log analysis. So that was it for our log operations room. If you got value from this video, or if you got value from our channel in any capacity, I do invite you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And there's a lot of videos that are constantly coming out, and I just go deeper and deeper into my personal studies inside of cybersecurity and ethical hacking. So every time that I go along, I just create a new video. And I've actually been storing a lot of notes and cheat sheets and things like that, which I'm going to be releasing soon. So there's a lot of good stuff that I'm going to be releasing that I think you would want to get access to if you actually are serious about going into cybersecurity and pen testing and ethical hacking and stuff like that. So definitely go ahead and like, subscribe, turn on the notification bell, drop a comment. I do respond to the comments, so we would love to have you in the community. I would love to see you in the comment section. And yeah, that's about it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I will see you in the next video for the next room later. Alright, today we're doing the log universe room, which was a continuation of the log operations room, which was a part of the SOC level 2 pathway of TryHackMe. So log operations room was actually part of the pathway. The log universe is not a part of the pathway, therefore I haven't included it as the actual SOC level 2 pathway series. But I think I'm just going to label this as episode 2A, or maybe episode 2B or something like this, just to kind of keep it in line with everything that we talked about in the log operations room. So that being said, what we're going to be talking about, or what we're actually going to be doing, because in this last one right here, we did mostly talking and there was just a lot of read through that we did. But in this one, we're actually going to be going through logs. So we have a virtual machine that we're going to launch, and then we're just going to kind of go through logs. So that's basically what is going to happen in this video today. So the intro to this particular room is actually pretty straightforward. We're just going to go through various log types, and then we're going to carve data from those log types. We're going to pull data from those logs. The learning objectives are how to identify and use different log sources, understand what to expect from different log types, and gain hands-on experience in data carving from the log files. So I love hands-on stuff. I love practical exercises, and this is one of the reasons why I love TryHackMe so much. So if you have not gotten your membership to TryHackMe, I would highly recommend that you get it. There's a discount link in the description below. The prerequisites for this room are working knowledge of Microsoft Windows and Linux, working knowledge of network and endpoint log systems, which are things that we've already done on this channel. So you can just look up Microsoft Windows and find some of the earlier videos, which will be more of the introductory videos. Same thing with Linux. Network and endpoint log systems would all be under the endpoint detection and incident response, or endpoint detection, EDIR. Yeah, I think so. I think that's what that would be, EDIR would be endpoint detection, incident response. So those would be the videos that you could find. We already did the video to intro to logs. We already did the log operations videos. And by the time that this video comes out, these two are already going to be up on the channel. And then there's the Windows event logs, which I think I've also already done. So let's kind of zoom out and see. I already did this as well. So Windows event logs will also be on this channel. So if you want to go find that video, if you haven't seen that already, you can go and see that as well. So those were the prerequisites for the log universe room that we are in today. So let's jump into this. All right, logs are obviously very important. They are the digital component, or the footprint, the digital footprint of what happens inside of a network, inside of a computer or a phone or anything like this. Logs are super important, but to be able to get the most out of them, you need to understand what types of logs there are, the formats of the logs, what they actually offer to you in the context of information, and what you can pull from those things. And then once you actually have an understanding of that, then you can start pulling the information, because you could be digging through something that has absolutely nothing to do with the incident that you're trying to solve, and you could be digging through that thing for hours and not find anything because you were looking in the wrong place the entire time. So that's what it means to know what types there are, what formats there are, and what information they hold, and how you can get the information that you actually need. The logs provide visibility, context, and carry evidence value in security operations, incident response, threat hunting, compliance, cyber resilience, and cyber maturity. Most importantly, the ability to correlate simultaneous and distinct events among distributed networks and systems is also achieved with the visibility and context that has been gained by logs, right? So this is very important and really good to understand. So these are some of the sources that you will find when you actually go, the sources that generate logs, right? So these are the various sources that will generate logs for you. You have physical sources, so facilities and areas where critical systems are hosted. Then security camera surveillance and access logs of physical entry and exit from a system control room or offices. These are physical locations and physical items that will generate logs. And then the virtual stuff is much bigger, right? The virtual list is much bigger. So you have network components. So you have the logs that are generated by network devices like routers and switches and plug-in devices like wireless access points and stuff like that. Then you have operating systems. So anything that, it could be iOS, it could be Android, it could be Windows, it could be Linux, it could be Unix, Mac OS, etc. Then you have the server. You have security appliances. So security appliances are a big one, especially because we're in cybersecurity and that's what we're studying. So there's the firewall log, the antivirus or malware log, the intrusion detection system log, intrusion protection system log, or intrusion prevention system, the data loss prevention logs, the VPN virtual private network logs. All of these things are under security appliances. And then of course you have applications and frameworks. So .NET, Java, PHP, Python, all of these things generate their own logs, application logs. You have mobile device logs, virtualization, cloud components, databases. There's so many of them. And this isn't even the full list, right? So that's what's crazy about the spectrum, the world of logs. There's just so much. And the Intro to Logs room covers common log types, right? So if you haven't seen that, go check that out, just so you can understand, or you can just skip to that particular part of the video so you can understand just how many different types of logs that you can actually deal with, especially in the world of cybersecurity. So data specifications are very important. So there's a lot of sources that you can generate logs from for different purposes. But to avoid noise, this is a big part right here, to avoid log noise and to enable log management, correlation, and investigation, some minimum qualification requirements have to be present. And these are some of the base qualifications. So the system that created the log needs to be in the log information. So what was the system that created this log? The creation time. This is very important. So the date and time and the time zone that the log item was created, so the specific event inside of that log, that needs to be inside of all of the logs that you're because you can't connect the dots. You can't correlate. That's the specific term. you can't correlate the events of the log if you don't know what time and date these things happened. And it's very, very important. And the time is actually an interesting one because it goes like down to the millisecond, right? Because some events happen so quickly that you need to be able to like, oh shoot, like these things happened within, 10 milliseconds from each other. This could be related, right? Then the event that caused the log to be created, right? What was the message that the system gives us that, hey, this is what happened and this is why we're logging this? The severity of the log, that if you can get that, that's very important. And the source associated with the log. So the IP and port number on both sides, meaning the destination IP and port, the source IP and port. The MAC address, which is the physical address of the device that you're dealing with. It's the manufacturer, I believe. That's what it stands for, MAC address. Let's Google it so we can actually get the specific definition here. The MAC address is a unique identifier, da 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 da. It says, let me see, what does it stand for? I want to know what it stands for. Media access control address, that's what it is. So the media access control address is what the MAC address is. And if you can get that inside of your log, that would be great. The username of the account, or the person that attacked you, or the person that created the log item, anything, the username would be super useful. The system name, super useful. And this could be the host name, it could be the computer name, the device name, whatever, because devices get their own individual names and you could have multiple users on the same device, right? So if you can't get the username, it would be very useful if you can at least get the system name. And this is just base qualifications, right? If you can get more, that's great, as long as it's relevant, because you don't want irrelevant information. But this is base information. If you can get that, then you are golden. So this is the treasure. These are the things that can help us get some really good data from our logs. And this is now where it gets fun and we actually get to go into the virtual machine. Here we go. The virtual machine is up, or well, it should be up in a couple of seconds here. And once that is up, we'll actually jump into it. Let's read through this real quick. Okay, so the virtual machine that we're going to be using is an Ubuntu machine with an open source log parser, which is called ulog viewer. And there are sample logs that we're going to be investigating as we go through this information. There's going to be an in-browser access for us. There's data sets that we can use on the desktop, and Windows, Linux, and Apache logs that we're going to be going through. I've already clicked start machine, so that's all good. Then these are the types of tools, I guess, that we have access to. Oh, it's basically kind of telling us how to navigate this whole thing. If you don't know how to navigate, the text files and how to save something and how to open something, this is what all of this is for. So the application logo is located in the desktop folder. You double click it, it's going to start. The application will ask you to choose a log file. There are 4 pinned options that are ready to use already, which is right here. The Apache Access Logs, Linux, raw text, and Windows event logs. And then we have task 4, which is going to be our Windows. Task 5 is going to be Linux, and task 6 is going to be Apache. And these are all the stuff that's already on the desktop available for us. And this specific thing, it seems to be the actual screenshot from the tool that we're going to be using. So once you open the application and you couldn't select a profile and ended up with an empty screen like the one that's right here, you can do this, right? So you click 1 here, you click the log profile to be parsed. Number 2, you add the log profile to be parsed. You filter the logs to perform the search using 3 right here. This is how you enter your filters. Delete the loaded logs from the UI, which is going to be the little trash button right here. And then open a new tab for different log sources, which will be that piece right there. So pretty user-friendly, pretty intuitive. And then in addition to this, the image below shows what to expect after data parsing and viewing the log message with filter options. So once you've actually implemented some kind of a filter and you're looking at your information, this is what it's going to look like. And then if you want to view more, then you click on that and it will give you more information about that specific line item inside of the log. So that's all we got, and our machine is already up, and I'm super excited about this because I like practical stuff. So here we go. So the first one is going to be the Windows Event Log Anatomy. What's important about this specific piece right here is this part where it says the logging scope is fully configurable and the default settings are not enough for the current state of the threats. Being comfortable with logs is a vital skill, but it's also important to have the general characteristics before deep diving into each log source details. So let's look at what the characteristics are, and you can then configure them, right? So the format / extension right here, the default format, or actually this is, I guess, format / extension. So this is what's going to be the extension of the event logs themselves. And then what can be extracted in the following formats. It could go into XML, CSV, or TXT. I highly recommend to do either CSV or XML because it provides at the very least some kind of a field name, and you can parse through it a little bit easier, especially if you're looking at it in raw format and not doing anything using some kind of a tool. The file locations are going to be in these environments. 2003 and earlier versions of Windows, it's going to be inside the Windows System 32 configuration, and then in the Vista and newer is going to be System 32 Win event and then logs. And then of course the defaults is going to be the event viewer that's going to help you with that. Then there's alternative tools that you can use, like the tool that I think we're going to be using today. Windows event logs can be generated and stored in a variety of extensions. The alternatives here provide great flexibility in the logging and analysis process, allowing the environment to be painlessly set up for the analysis phase and taking advantage of alternative components. After getting familiar with the log file formats, it is time skew to identify that. That's a misspelling right there for sure. It is time to identify the event log file categories. By default, there are two main log categories in Windows. The details are shown here. So you have the Windows logs and then the application and service logs. And this is what it looks like. And this is our screenshot, which, I mean, it doesn't really tell you much. So for Windows logs, is the built-in Windows event logs. The main focus is system activities. It's not customizable, and it gives insights to the overall system. Application and service logs are more specific on individual application services. They can have custom log formats, and they give insight on particular applications and services. So you have hardware events, Internet Explorer, key management, OpenSSH, Windows PowerShell. These are all applications and services. The application security setup system, these are all things that are inherent inside of the Windows machine. You cannot customize those, but application and service logs you can customize. And of course, since there's a lot of information that can be achieved through Windows, we can get hundreds of logs for two categories that we just went through, these two categories right here. So some are commonly used and others need to be activated by configuration. So let's look at the common ones and what information they provide. So Windows logs could be for the application log channel, and it shows application and software logs. Again, Windows log, system, security, setup. So system is going to give you the OS and components logs. Security is going to give you local and group policy and audit logs. Setup will be application installation logs. Forwarded events, so logs sent from hosts that are residing inside the same network. And then you go into the application and service log categories. So PowerShell operational. So this is the detailed. I don't know why I can't see the full thing here. It's kind of frustrating. Am I zoomed in or something? Let me zoom out, see if I can get that right. Okay, well, that's a little bit annoying. But we can't get the full information here. So application and service logs, so it has the operational portion of PowerShell, focused on security, audit, and compliance, and scripts, detectability, modules, and administrator actions. Application and service logs for PowerShell. So PowerShell logs focused on debugging and scripts for diagnosing script issues. Detectabilities would be script execution and errors and script information. And then the hints and images right here, here we go. You can open and view the details of this, yada, yada, yada. Log name, source, event ID, the level, information, error warning. This is important. This is something that will tell you whether or not you need to be addressing something right away or you can disregard it. The user, the logged event time, the task category, process creation, service creation, or clearing of a log. This is also important. When somebody clears a log, you want to know why they cleared the log, and if anything shows up that is a log clearance, you kind of want to think about it. It could be somebody that was inside the system and they're trying to erase their tracks, and so they cleared the log. So when you see that, it should kind of notify you that this might be an event of interest. You have keywords that you can flag, none, So these are standard keywords with the OS resources. So there's no keyword, no filtering is performed. There's audit failure, that the audit was failed, and an audit success. And then you have the computer itself, the host name of the computer, and the message that was available. And all of this stuff again is available when you click on the view more information. And this is where things get super interesting. So event IDs are where you can find information and you can look for like specific keywords on Google and say, what's the event ID for this? And when you go through Splunk or Windows Event Viewer or any of these tools, you won't really you're going to get the event ID more often than you would get the details of the event that you can track back to. So if you see an event ID that seems sketch, or if you don't recognize it, you can go and search for that event ID, and it'll give you a detailed description of what that event ID belongs to, and you'll now know that, hey, this is a big this is like an important thing to consider. And there is no, the same event ID isn't going to be used for different things. So for example, 4720 won't be used for anything other than user account creation or the activities that go involved with that. 22, user account enabled. 23, attempt to change an account password. The user attempts to change their own password. 24 would be the reset account password. 25 is account disabled. 26 is account removal. So the 20 series, kind of as you can relate right here, there's 21 that's missing, but 20, 22, 23, 24, 25, 26 all have to do with new accounts or accounts being changed, something like that. Account logon, so 4624, 4625, 4634, and 4779, right? Successful logon, failed logon, this one's kind of more important, I think, in my opinion. 4634 and 4647 are log off. 4779 is session disconnected. Scheduled tasks could be a scheduled task was created, and we did some pen testing activities where we created a scheduled task because there were certain files that had SUID permissions, so the super user or the pseudo user permission, that they could be launched as an administrator, and we created inside of that scheduled task a script that we wanted to take over the system, and as soon as the scheduled task ran according to a scheduled time, we were able to get a reverse shell into that system. If any of that goes over your head, then go watch those videos because they're super useful. Scheduled task creation, scheduled task update, scheduled task deletion, and then security right here. So the 1100 series right here have to do with security, logging service disabled, log deletion, malware detection, all of those. These are event IDs. This is like super important. And there's so many of them. Obviously, as you can see, they're in the thousands. So each source produces different logs for different purposes. The intro to logs will talk about the log formats and standards. You will find more information if you're getting familiar with logs. You can also visit the Windows event logs and Sysmon rooms, which both of these have videos. So you can go and look at the Sysmon video. You can go look at the Windows event logs video inside of this channel, and you'll get much more information on that for more details about the event that you are interested in. So now we're going to go to the machine and answer the Windows questions log file using the ulog viewer. So I am going to now open the ulog viewer. Hopefully it'll open quickly, and within that we're going to answer some of these Windows questions. Alright, cool. So this started and it got us to our thing right here, so we can actually use our little icons for the type of log that we want to view, but it does say no logs to show. What I'm going to do is I'm going to open this up in full screen mode to make it a little bit easier for us to access this whole thing. There you go, that's much better. And so what did they say? They said that we could click on this thing right here and pull our new logs that we need to pull. We did Windows event logs, and then now I'm going to click on this to actually select the log that I need, and it's going to be on the desktop. And so we have win questions, win sample. Let me see, what am I supposed to do? Hold on one second. Okay, cool. The instructions tell us that we need to do the Windows questions log file. So I'm going to open up this specific log file here, and there we go. Immediately it opened up. So now the first question says, what is the thread ID of the user creation event? So if I go here, let me see how we can filter this whole thing, and we'll try to get something for user creation. Okay, actually, so what we're gonna do is we're gonna go based on right here. So it's gonna be the 4720 event ID that has to do with user creation. So if we find that event ID for 4720, then we would be able to find the user creation TID, thread ID, and it's right down here. So 4720 is the event ID, and the thread ID is 744. So that's going to be our thread ID for this. And now it says, what is the account name that creates the new user? And we see it right here. So the target username is administrator, target domain name, SUID, subject username administrator. So it seems to be administrator. So let's see, this is the domain name, which is an Atomic Bird. The SAM account name is administrator. Yeah, I'm going to say that it's administrator. So that will be our answer. And what is the name of the created account name, which was created? So target username administrator, target domain name, SID is right here, da 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 da. So this is the account name that was created based on the hint that we had. And it's funny because this doesn't say administrator, it says administrator. So this is what they've tried to do to kind of avoid detection, is that this is the proper name, right? Administrator, but subject account name or the SAM account name is administrator. The target account name is administrator. So that's what they've created. So we're going to do that, administrator, and that will be it. And what is the subject logon ID of the account reset attempt event? So the account reset attempt, is that what it says? Account reset attempt. Yeah. So the account reset attempt right here would be this thing. So 4724, and we got, what is the subject logon ID? So 4724. Let's go find that. It's right here, 4724, and the subject logon ID is administrator. Subject logon ID is this thing right here. So let me see if I can copy this. Perfect. Copy, and then we're just going to go and drop it, and voila, there we go. Nicely done. Easy does it. So there we go. That was our first series of Windows event log analysis. That was not bad at all. Fairly straightforward and easy to do. So now what we're going to do is we're going to look at the Linux logs. So let's look at the Linux logs. All right, Linux logs are, I mean, for the most part, it's going to be pretty similar to what happens on what we learned from the Windows logs, except the log format name extension is very different. Obviously, the location of it is going to be different. It's not going to be as robust, meaning that you're not going to get as much information as you did from the Windows logs, because if you remember, there was the system logs themselves, the Windows system logs, and then there was all the application and service logs. For this, it doesn't tell you all of that stuff. So what we can do is we can kind of incite those logs to happen by commanding Linux to do it for us. But in this particular case, we're not going to be doing that. In this case, we're just going to be looking at the general system logs that are going to be generated. And Linux in general, especially if it's just a command line version, because there's like a very, very basic version of Linux that's super command line driven. There is no GUI, there's no graphic user interface. Therefore, you're going to be only working with the command line and all the logs that are generated for that machine and all of its limited sources that are generated. If you download any kind of an application, then you can, or I think they call it packages. They don't really call it applications. But if you download any of those things, then for each one that is downloaded, you can choose to actually have logs created as the system continues to process it. So you have the general system logs, authentication logs, the daemon logs, and the daemons are very similar to the kernel, but you also have a kernel log right here, system boot logs, the debug logs, the apt command. Apt is used for installation and checking if things are installed, background device logs, audit logs, failed logins only have their own thing, and you can look at that by doing fail log. Last logins can be done with last log. Active logins can be done with who, not to be confused with who is, which is all one word. Who is would be one word, but who specifically looks at who, the active logins. And then we have the kernel ring buffer logs, and all of these things can be accessed with a simple command. So the stuff that's going to be inside of these things are the timestamps, hostname, application, process, name, process ID, message ID, and the message itself. So similar, different from all the information that we got from the Windows logs. and the IETF. So while the RFC defines the main structure, there are alternative implementations of message presentations. The common structure is IETF. So IETF log format will give you the timestamp, host name, process ID, the PID, and the message associated with it. And then you have the sample log, which is the syslog. That's what we're going to be looking at right here. This item that you see right here, this is a sample from the syslog in IETF format. So you have the timestamp, which is this whole piece right here. It has the date followed by the time. And then you have the name of the host, which is the temp server. You have the process PID, so sudo 2345, and then this is the message: authentication user Alice executed command user bin apt-get update, right? So this showcases an event where the user Alice executed the command update for the apt using the sudo command on the server, temp server. This log entry provides valuable insights into the user actions, including the executed command and the authentication details, which can aid in auditing and monitoring system activities. As the previous example shows, reading and understanding a single log entry in a structured format can be relatively straightforward. However, the challenge increases when dealing with voluminous log files containing numerous lines of entries. In such cases, extracting the relevant attributes and establishing correlations becomes essential to comprehensively understand specific events within the log file. Analyzing multi-line logs requires high attention to detail and the ability to filter and extract significant details. This process involves identifying and filtering timestamps, hostnames, process IDs, and event descriptions, among other critical details. By effectively analyzing and correlating these attributes, it is possible to uncover the sequence of events. In summary, while individual log entries may seem manageable, the complexity arises when dealing with large data sets. The magic lies in organizing and extracting the analysis of keys and attributes to reveal the underlying story. The following examples are a series of timestamp entries from temp server that show critical system events and resource management. So we got at this time, it says the temp server kernel out of memory killed process 5678, which is my app, and the system reboot was required. And then temp server memory C group out of memory kill process database, score 500 or sacrifice child. Then temp server against system reached memory limit, restarting. Temp server swap space exhausted, system restarting to free up memory. Server running low on memory, initiating reboot for recovery. So it shows that the temp server that included crucial memory related events and the process 5678, which is called my app database, and then 1, 2, 3 more, they all cause memory problems and could be resulted in terminations, memory limit violations, and that could be for a number of reasons, right? So a lot of the stuff that I've seen for memory consumption could either be like a crypto mining application that was installed on the machine and somebody was using that machine to mine crypto and then they were sending it to their wallet, or they had installed some kind of a command and control C2 connection where they were beaconing information from this machine to their own command and control server, and they were just extracting data, exfiltrating data. So there's a lot of stuff that could be done with just finding why this system is crashing, like what's going on, why does it keep rebooting, because it's running out of processing power. That doesn't seem normal, right? So what we're now going to do is we're going to go look at the Linux log file using our ulog viewer, and we're going to select the Linux system log files and then provide profile to view and filter the logs, and the sample log is parsed shown in this event. So let's do that. Let me zoom out here. Let's go here, we'll close this, and then we're going to now click on this button, and then we're going to do Linux system log files. And then we're going to click on our little add log button here, and we're going to click on the Linux log and open this thing. And it opened pretty quickly, so that's nice. Doesn't seem to be too many lines of items here. And notice how this is actually very different than the format that we saw from the Windows machine. So let's look at the first question. What is the number of successful sync events done by the NTPD service? So successful sync events by NTPD service. Okay, so the first thing that I searched for was NTPD, and it shows me all the processes that have to do with NTPD. And then there's another thing that we see right here which says synchronized to, etc., etc. So I'm going to try to filter for both of them. NTPD comma synchronized. Let me see if that works. Nope, it doesn't work. So we're just gonna do synchronized, and it should only show us our synchronized items. And then this is what we got. So there we go. This is only synchronized items. So if I said, let me see if I can click on something that will show me how many. Oh, right down here. It says, so the total line items are 74, and then the filtered are 28. So there are 28 items that have synchronized. So let me see if that's the right answer here. There we go. That is the right answer. So which user logged in using the SSHD service? So then what we can do is we can just type in SSHD and see something comes up. There we go. Process SSHD. And it says which user did it. So if we look in right here, it says THM John-P, 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 John-P. So that seems to be the user. So I'm going to do THM John or THM John-P like that. There we go. What is the PID number of the Apache server? So PID of the Apache server. Let's clear that out. And we're going to look for Apache, and it's right here. And so Apache server PID 5678, 5678, 5678. So we're going to say that the PID is 5678. There we go. What service is stopped due to RAM issues? So there we go. Now we're getting down to some interesting things here. So I'm going to search for stopped first, just to see if anything shows up. There we go. MySQL server stopped unexpectedly due to excessive CPU usage due to insufficient RAM is Nginx. So Nginx was stopped due to insufficient RAM. So let's try that. Nginx. There we go. Making some good progress here. Which service is stopped due to CPU issues? So we already have stopped loaded, and it says excessive CPU is Apache Tomcat has been stopped. So let's go and check that out. And there is that. And finally, what is the timestamp of the second time reset event? So let's see what our hint gives us. Whole timestamp data is what we need. So the second time reset event. So let me see. I'm going to do reset as my search right here. There we go. So second one, these are in order right here. So 301 would be the first one, 327 at 15, 327 at 16, and that is the second timestamp. So can I like copy this value? There we go. I'm going to do this, and I'm going to copy this entire value. Voila, and we're gonna go here and we're gonna paste it, and boom. Why is it wrong? What's the format that they're looking for? Is that the wrong one? Let me see. Maybe I got the wrong information here. Oh, the second one. The second one. Dude, I'm such a dork. Unbelievable. That's the second one. I pulled the third one. That's the second one. There we go. We got it. Nicely done. Yay me. Okay. All right, cool. Now moving on to the last one, which is the miscellaneous logs for Apache. Let's get this done. All right, application logs here falls under miscellaneous. So application-based events, giving more insights on applications and process-based details that will help Apache is also a log file inside of Apache logs, just based on the services, I guess, is going to be different. So the location of them are going to be different. This all seems to be Linux, right? So the var-log is a Linux type of a syntax. So it could be Apache 2, Apache 2 access log, Apache 2 error log, etc. So the main directory is inside of Apache, and then inside of Apache you're going to find a bunch of different types of logs. The default is going to be system log viewer, and then you can have different tools, or if you could, these are all command line things. So cat will just list the entire thing, tail will list the last 10 lines, less will give you page by page, etc., etc. grep will search through it. So these are all command line tools. This, I think, is an actual a log viewer package, maybe. So access logs are invaluable records generated by web servers containing essential attributes. These attributes include IP addresses, timestamps, HTTP methods, URLs, so on and so forth. The IP address could be something like this, %H, which is the IP address of the client, which is the requester. %L is going to be the represents by the hyphen, which is the dash, and it appears when the requested information is not available. %U for user, the user ID information. %T would be the time information. \, quote, %R, \, which is the request that was made. And then this is like the greater than sign. S, and it's the status code that is sent back to the client. %B is the size of the returned object. %referrer I is going to be the referrer, whoever referred the HTTP referrer field, and then the user agent would typically be something like Mozilla or whatever the application was, that the application and operating system that sends the request over. So this would be the combined format, right? So you have the log format, and then it gives you the order that the information would be presented to you, and it's a combined log, which means it will show you more than the standalone. It was actually in the last video that we, not the last video, but the very first video that we did. There's a version that's combined, and there's a version that's like basic. And so this is what it would actually look like, right? So this is the IP address that came in. This is the user that came in, THM John. This is the timestamp that came in. And what do we got? This is the request that was made. It was a post request right here. This is the status code, the ID. This is what they were trying to request. And then this is the user agent right here. And the user agent usually is the biggest piece of data because it shows you everything. The, Mozilla, Windows NT, Apple WebKit, Chrome, Safari, right? So this is like the full user agent that was used right here. So the evaluation from this is that the above log file showcases a client IP, which is the very first thing that we see. It made a post request, meaning it wanted to send data to the API data URL on the server, which is this piece right here. And the response that they got was 404 not found. And the client was referred by the Login Universe THM page using the Mozilla web browser, right? So note that the web browser and operating system information can be manipulated or changed by the attacker crafting the custom packets or using an attack or audit tool just to mislead you on what they were doing. This is what a sample log would look like, and we're just going to look at that right now. And then the Apache log, which is the error.log that we're going to be looking at, is going to look like this. It has the timestamp, the level, so the log level of the message, the process ID, the source file, the error status, the client IP, and the actual log message, which is going to look like this, right? So the timestamp, the log ID, or the log level, excuse me, the process ID, the source file itself, and the error status code, the client itself, the client's IP address and port information, and finally the message. So that's what we got. This is our timestamp complete right here. We have the error that shows up right here. So this is the level of the error, right? This is the process ID that we got. This is the client information. And we got file does not exist, which is the error message itself. And then the full message right here. Or actually, I think this is probably the full message right here. So this was the client. This is the PID. The E is the PID? No, the PID is for P. So we didn't get all of this information. We didn't get all of these labels right here. Or at least I don't think so. Because the T would be the timestamp. The L would be the log level. So this is timestamp. This is the log level, which is an error log. Or error log item, especially. The PID would be the process ID, which is this thing right here. So far so good. After that, we would have the source file and the line number. So I guess this is the source file. So client is the source file, and it's on line 1, right? So far so good. And then we got the error status code, which that I don't see. And then we got the client IP and information, which I don't see. And then we just got the actual log message. So after this, we only see the log message, right? So it says the above log shows that a loopback address at 1, which means an internal request made to the resource favicon the favicon icon located on the same server. The message part highlights that the directory user doesn't contain the requested file. The error is valuable as it shows that it's missing a resource on the server. This can help with the administrator identify and fix the resource availability issue. Note that : 1 is a loopback address, which is the local IP address that we see right here. This is an IPv6. So this is an IPv4 address. This is an IPv6 address. That's actually, I didn't know that. So that's good to know. Now we are going to do the same exact thing on this little machine that we got. So let's actually go ahead and do that. And we're going to be using the Apache files, the Apache error log file. Okay, so the instructions told us that we need to use the raw text in files format for this Apache right here. So we're going to end up using this thing. And then from here, we're going to go ahead and select our Apache error log file. And there is that, and boom, here we go. We got it, and we got all the line items here. So let's see, what's the first question? It says, what is the user's IP address who accessed /secure.html in defanged format? Defanged means that the dot right here is surrounded by brackets. And so what we're going to be doing is we're going to be, whatever the IP address that they gave us, we're going to select it, or we're going to put it in defanged format. So I'm going to go to CyberChef, and CyberChef allows us to do defanged very quickly without me having to, put in a bunch of stuff. So I'm just going to go right here. I'm going to do defang IP addresses, and we're going to we're going to do that. And then now we're going to go here, and then what we wanted to do is we want to search for secure.html. So we're going to do /secure.html. Let me see if that shows up. That doesn't show anything. /secure, does that show anything? That doesn't show anything either. So I guess I got to kind of browse through it like this. That's kind of weak. Like, I feel like it should like show me that, right? Like I should be able to search through the thing. Maybe I can use a different tool to search for it, because that seems silly that I can't search using just a basic. Maybe I can do Control F. Can I do Control F to search? Yeah, I mean, it just shows me the same thing. So what if I just search for secure? No, doesn't show me that either. Okay, so I have to manually look now. That seems very, very silly. So let's see what we can do though. We're looking for secure. Okay, my dear friends, learn from my mistakes. So this is what happens when you don't read properly. So what this piece right here is just saying that this little screenshot is from reading the Apache error log file. Right here, it's saying use the access log file to answer the first few questions. And I was searching for this inside of the error log file for like 10 minutes. And I'm like, why the hell can't I find this? And I was so pissed. And then I found out that I was looking at the wrong log file. So now what we're going to do is we're going to go through our access log and do secure. Look at that. Immediately it shows up. My God, I'm so I'm so mad. Okay, so there we go. That's it. So the request was a GET request on the secure HTML, and they want the source IP to be defanged. So we're just going to copy this, and we're going to go to defanging right here, input that, and look at that. Immediately it just gives me the defanged version. And then we're going to go and paste that here. Damn, bro, I can't believe I didn't notice that. Okay, so now, which user failed to access the settings page? So that's the next thing that we're going to search for. So I'm just going to go up here and just type in settings, and it's going to give me that. And it said it's a 404 error, so we know that they weren't able to do it. And it's settings, and the user is let me see, can I split this? Buyer 986. So buyer 986 was trying to get to the settings page. Which user accessed the malicious page? Oh, interesting. What's the hint here? Status codes are important to notice. Regex hint, payload, password shell is what we're looking for in this case. So let me see. What I could do is I could just do all 200 statuses, which will show me all of the successful accesses right here, and we can look for a malicious page in this particular case, and right down here it says malware.php payload, etc., etc., and that would be adversary 8779. So I filtered for status 200, but if this was a much bigger file, obviously I would be getting a lot more requests that were successful. So this kind of works for the thing that I'm trying to do, but if we really wanted to kind of do what they were saying, I could just copy this regex command right here, and this is the payload right here. So this is payload, etc., etc. So I could just go there and I could paste that, and that should bring us all of the, well, it brought everything. So it brought all the things. So virus.php, malware.php, and there's a few different ones. Vulnerability exploit. So it's a few different ones. The original one that I found when I did a status 200 was the malware, because if you notice that this one is failed, so 404 is failed, 404 is failed, 403 is failed. This is a denial from the server. 200 is the only one that's actually successful, which would be adversary 8779. So it would be ADV 8779. I added a 3. There we go. Cool. And finally, what is the user agent that discovered the malicious page? So what is the user agent that discovered the malicious page? And it's going to be this thing. So Nikto OpenVAS. Nikto is a cool tool. There we go. And there it is. Okay, now I can go to the error log file to answer the rest of the questions. I can't, man, sometimes I make some silly mistakes, man. And I spend so much time just losing my mind because the initial approach that I had was so incorrect. Okay, so there we go. Now we're in the error log file. So it says, what is the PID of the process that causes a permission error? So PID of the process, why can't I zoom in here? There we go. That causes a permission error. So what is the PID? What is a response code for permission error? The response code for permission error is 403 forbidden. So what we're going to look for is 403 in all of our stuff, and there we go, access denied with 403, and what we want is the PID of that, and so we're going to look for PID right here. 6543 is the PID. So 6543. No way, that's not right. Okay, so let's see. Okay, so searching for permission gave me a different PID. So 7654 could possibly be it. If 6543 wasn't it, let's see if 7654, yeah, 7654 is it. So instead of searching for a 403 response code, I just searched for the word permission and found that. So what is the request that contains an invalid method? The request that contains an invalid method. So let's search for invalid method in request, and I think both of them are both exactly the same, and they're coming from different IP addresses, but they both have the same exact invalid method request. So I think this is it right here. So we're going to copy this thing, and we're going to go. You notice how, like, it's so much easier to use a tool like this to actually search through these files. But essentially, if you were using a command line tool, you would pretty much do the same thing. So after this is over, I'm going to just try to do like a grep command through the log file and just use the terminal to see if we can find the same information just using the terminal to do a grep command and search for some of these things. So what pattern match triggered the access error in mod security? So in this particular case, what we're going to do is we're going to search for mod security, and then we have access error, access denied with code 406, access denied with code 403, pattern match select dot plus from. So that's the pattern match, select dot plus from. I believe that is it. So select dot plus from. Okay, that's not it. Let me see. Oh, I see. So I had to include the opening and close parentheses in order for this to work. So it was right, but we just didn't, not parentheses, excuse me, quotes, the open and close quotes. You had to do that in order for this to work. Okay, so finally we have, what is the path value of the file that tries to remove data from the system? Ooh, interesting. Path value of the file that tries to remove data from the system. So let's see what we can search for here to actually make that work. So let's see. Okay, so the first thing that actually brought something back for me was when I searched for data. And when you go there, you have a path value right here. That is the HTML private data right here. So let me see if this is the path value. Maybe we'll get lucky here. Let me see. That is not it. So that's not it. The path value of the file that tries to remove data from the system. Let's see. Okay, the other search that I did was for the word file, and we got a few errors here. There's a lot of them that are file not exist, and then file permissions deny, and then this one right here, PHP warning file get contents. This seems very much like what we may be actually looking for, and so this is the path value of the file that tried to remove data. Maybe, we'll see. Hopefully that's it. Otherwise I'm gonna have to keep searching. Let's see if that's it. That is not it. All right. So let's see what else I can find here. Okay, so the other thing that I searched for was RM. And RM in Linux stands for remove. So when you're trying to remove something, you would do RM followed by the path. And so the first one is file permissions, deny server, config, yada, yada, yada. So we already got that. This one seems to be interesting. So it says syntax error. And then right here, look at that, invalid command RM, so remove. And this is what they're trying to remove, it seems, is this piece, etc, http, yada, 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 yada. So this is the configuration file for malicious.configuration. And this, maybe third time is a charm, right? I think that's it. There you go. We got it. Okay, super, super stoked about that. All right, so as I promised, I'm going to try to now locate all of this data by just parsing through the file using the command line instead of using this tool. And hopefully we can just find a few of these things that were, hopefully useful. So in this particular case, I'm not gonna go through all of them. I'm just gonna try to find a few of these things with the hopes that we can actually get some information. So let's see. We're going to do. Let me first open it up, and then from there we'll try to find this information. Okay, so since we are actually inside of a Windows machine, I thought we were inside of a Linux machine or some kind of a Ubuntu machine, but we are inside of a Windows machine. So the syntax is going to be a little bit different when you're trying to search for something. So first, you can use the same thing for CD, which means to change directory. So this is originally when I opened it, this is the path that I was on, and then I would just do CD desktop to take me to the desktop, because as you can see, all of our log files are on the desktop. And if I just do a dir, it shows me all the log files. So that much we got. Now, instead of doing cat, because that's a Linux command, what we're going to do is we're going to do type, and then we're going to do access, or not Apache, excuse me. We're going to do Apache error.log, and then it'll print everything that was inside of that log, right? So now we see everything. So the next thing that I want to do is I want to find something inside of this. And typically, when you're doing Linux, you would do grep to find something. But inside of Windows, I believe it's called find str, so for find string. Let me double check, because I actually had to Google this. And yeah, it is find string. So find string is what we're going to do. So I wonder if we can just pipe it into our command, or if I can just do a find string. So I'm just going to do find string in this particular case, and I'm going to search for one of these things. So I'm going to do, type such and such and such, and then I'm going to do find string permission, right? So let me do that and then see what we can find, right? So we're going to do type. Okay, look, it worked. It actually worked. So same thing, right? So if you actually know how to type what you're looking for, if you know the syntax of the command line of what you're looking for, you'll be able to get basically the same information. And this one was kind of a little bit faster, right? Because if you know how to use the command line, you just get into the command line. You don't have to wait for the application to open. You don't have to go find the file and load it and all these things. You could literally just start searching through the file. And it's actually much faster because when you use an application like this thing right here, you would have to wait for the log file to populate before you can search through it. But when you're inside the command line, you could basically just start searching through it, right? And this is it. This is exactly what I did when I was inside of the application, that ulog viewer or whatever it was. I just looked for the string permission and it gave me the line item, and then it said, look, file permission, deny server access on this thing. And I think that's the full line, right? So like yeah, that's the full line. And so this is the path of the configuration file, and then the PID 7654. That's what we were supposed to find right here, which we did. So what is the request that contains an invalid method? So I think the thing that I searched for in that situation was method. So I could literally just do the same thing, go here and just do method, and there we go. We got invalid method in request, and it gave me both of those things. I mean, that's pretty freaking cool. That's like much more useful in my opinion. I don't know. It was just super fast the way that it happened. And then so, you know, mod security, right? Which pattern triggered the access error in mod security? So I could do the same exact thing again. I can just do the same command right here. I just press up on my keyboard and it loads the last command. And then what I'm going to do is just find for the string of mod security is what I'm going to look for, and it'll bring me all of those lines, and it gives me access denied in the code, phrase match for admin, and it's the username right here, and then phrase match, boom, right here. We got the select from, and that's our pattern match error. So you could do the same exact thing that we just did using that log viewer with just using the command line. As long as you know the syntax of how to read files and how to search through files, you could do it just as easily using the command line. And I would argue that it's even easier, because if you know the syntax of what you're looking for, it's so much faster and it brings you the results right away, and it's just way, way, way easier. So that was my little extra bonus for you for sticking it out to the end of this video, and you've learned how to do it with the command line inside of a Windows machine, which is actually not natural for me because I usually use Linux and I'm much better with the Linux syntax. But this was cool for me too, just to kind of get a good idea of how to search through it. And all I had to do was learn that find str, find string command, and that was pretty much it. So yeah, that's it. That's it for our log universe video here, and the conclusion is very basic. So it's like, you know, congratulations, so on and so forth, and time to visit advanced Slunk and advanced ELK modules, which are actually inside of the SOC Level 2 pathway that we're on. We're going to be going through advanced Splunk, and we're going to be going through advanced ELK. But before we do that, we got to finish up our log analysis module right here, which includes one last item, which is the intro to log analysis. So we got intro to logs, log operations, and now we're going to go to intro to log analysis in our next episode, and that'll be it. And then we can go into advanced Splunk. So super exciting. I'm very, very happy to actually be able to do this with you, and hopefully you got a lot of good value from it. If you did in fact get value from this video or from this channel, I do encourage and invite you to like, subscribe, and turn on that notification bell so that you can become a part of our community, and maybe even drop a comment. I do love seeing the comments, and I do love responding to the comments, and believe it or not, our comment section is super live. There are so many people that drop comments and ask some really, really good questions, and it just gets deep. Like we go back and forth in these comment sections. So this is a very, very cool experience for me. At first I never realized that it would actually turn into this, but the community has grown excessively, and we have so many people. Look at that. I mean, they're in the hundreds, probably in the thousands now, that we've gotten so many freaking comments, and it's all so rewarding. And it becomes a community. It's very much like a community. People talk to each other in the comments, and I just welcome you to leave a comment. I would love to get to hear from you, and if nothing else, I would love to have you as a part of our community. So make sure that you like, subscribe, and turn on that notification bell so that you can get notified the next time that a video comes out. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video for the next room later. Alright, in this episode we are going to go through the intro to log analysis room that is inside of the log analysis module for the SOC Level 2 pathway of TryHackMe. This is going to be officially episode 3, and it's going to be the very last room inside of log analysis before we actually jump into advanced Splunk and advanced ELK and all the good stuff that comes with SOC Level 2. So let's jump into the intro real quick, and then we'll jump into the contents of the room. Alright, the first thing that I want to tell you is this is actually a free room that's available on TryHackMe for everybody with a free account. You don't even need to pay for it or anything like that, even though it's super affordable. But you can use the link in the description below, get yourself a free membership, and even if you want, you'll get a discount on the paid membership. And yeah, you could do everything inside of this room for free. And I think there's actually going to be certain there's going to be task files and things like that, so that means we can definitely use the attack box, which I'm going to start right now just to get ahead of the game. And then yeah, that's pretty much it. So I do recommend, if you want to get the most value out of this video, to go ahead and get yourself a free account, and then you can follow along with all of the tasks that I do so that it registers even better inside of your brain and you just get the most value out of it. So the introduction here tells us as such. So let me get a proper zoom going. Okay, so log analysis is an essential aspect of cybersecurity and system monitoring. At a high level, log analysis examines and interprets log event data generated by various sources like devices, applications, and systems to monitor metrics and identify security incidents. It involves collecting, parsing, and processing log files to turn data into actionable objectives by adopting an effective log analysis strategy. Security team, or I'm combining these sentences, so period. And then by adopting an effective log analysis strategy, security teams can more accurately respond to security incidents and gain proactive insights into potential threats. In this room, we will explore concepts related to log analysis methodology, effective logging practices, and common tools to aid detection and response. Our learning objectives are going to be to learn log analysis practices, best practices, discover the essential tools for analysis, gain hands-on experience in analyzing logs by using multiple tools and technologies. And the room prerequisites are the intro to logs room, which we've already done a video for, so you can go watch that if you haven't seen it already. It should be episode 1 in this entire series, and then log operations, which should be episode 2 in this entire series. So those are going to be your prerequisites to get this ball rolling. And that being taken care of, let's talk about some log analysis basics. Alright, so if you don't already know what logs are, which I mean, hopefully by now you do, so I'm not going to spend too much time on this. If you really want to know what logs are, I would say go to the intro to logs video. So I'm really not going to spend too much time on this. But this is basically what you'll see right here is one line item from a log file, right? So at the very beginning, we get to see the time and date right here. Then you get to see the IP address that this thing is associated with. And then you get some kind of a warning message, so you get to know what this actually, the type of log item it is. It's a warning and it's general. And it says unusual network activity detected from this IP address to IP Source zone is going to be internal, destination zone is external, application, web browsing, action, alert. So this seems like it might be a firewall. Yep, right here. Exactly. Very good. I'm getting better at this. I noticed that it was a firewall thing. So this seems like a firewall log, right? So it came from a firewall log. We got a warning message saying that there was an unusual activity detected, and it tells us where it's going from and where it's going to. And internal and external is what kind of gave it away for me. Because internal and external is usually syntax that's referred to specifically for firewall logs. And that's basically it. You got an alert, right? So this is basically the alert right here, and it's saying that this particular IP address is trying to go here, and this is apparently either a denied IP address, or maybe this IP address isn't supposed to have any access to anything externally. So those are the kinds of things that would set off a firewall log, right? So the date right here, as we established. This is the system's IP address, the source that generated the actual log. This is the warning message, severity of the log, so it's a warning, which means it needs to be looked at very it's more important than informational, right? So we have 4 levels to this. We have informational, we have warning, there's an error message, and then there's a critical type of log item. And the critical ones are the ones that you got to address immediately, right? And so the action is an alert. So the firewall policy was configured to notify when something like that happens, and everything else just gives us more information specific to this thing, meaning that it was detected from this IP address and it's going to this IP address based on the source zone. The traffic appears destined for the internet, which is external, and the application was categorized as a web browsing type of an application. So the reason why this is important is that you get to do a lot of things with your log. So for example, if your system is crashing or if there's something wrong with your system, you get to troubleshoot what's going on in your system. And the log will help you do that because you can trace the steps as to where the troubleshooting error came from. The next thing would be there's a cybersecurity incident. So if something were to happen inside of the company that you're working at and you need to respond to an incident, the logs will help you figure it out. And for cybersecurity, there's a lot of different logs that you need to look at, and we call this correlation, where you connect the various logs to try to figure out what the overall incident was. And for that, you would use something like a security information and event manager, also known as a SIM, which would be Elastic or Splunk, and we have that set for the future videos that we're going to be doing in SOC Level 2. But, you know, cybersecurity incidents combine firewall logs, IDS logs, system authentication logs. All of those things combined give you the full picture of what's going on. And that way you can understand what the incident actually was doing, right? It's not one of those things is going to give you the full picture. You need all of those logs to get you the full picture, how to find malware, how to respond to an incident that just happened, how to backtrack and find the person that just attacked you, so on and so forth. Threat hunting is another thing that's really useful, right? So this is responsive, this is reactive. Threat hunting is proactive, right? So you're going after the threat, you're going after the person that attacked you so that you can prevent it from happening again, and maybe you can even find the person that actually attacked you, like something that happened to the MGM Grand where they were held at ransom, and it was like a really big attack that happened to them. I think it was like towards the end of 2023, and they were held at ransom for a very long time, and their entire casino was shut down in Las Vegas, and it was like a big deal. And so knowing how to hunt that person that attacked you and held you at ransom, I would assume would be like a big deal. I don't know if they actually did that, but I would assume that that's a big deal. And then of course there's compliance, which is a really big deal. So there's regulations that you got to adhere to, there's laws that you got to adhere to, there's a lot of compliance stuff that happens with every single freaking business. And the most basic one is GDPR, which is the General Data Protection Regulation, and it was founded in Europe. But if you do anything in Europe, meaning if your website sells to somebody in Europe, or somebody in Europe Googled you and found your website from Europe, that means you have to adhere to the GDPR regulations. HIPAA has to do with anything health information related. So HIPAA stands for Health Insurance Portability and Accountability Act. So if you're in life insurance, health insurance, if you're a private practice doctor, if you're a hospital, anything that has to do with somebody's health insurance information, that applies to you. PCI has to do with payment card industry, digital security standards. So, which means if you're collecting any kind of payment card in any capacity, in your physical location, on a website, if you're dealing with payment card information, you have to adhere to the PCI standards. So compliance is a big deal, and logs help you do those types of things. And in the intro to logs video, we went through all the different types of logs, and this is kind of a snapshot review of it. So you have application logs for applications, you have audit logs that help you try to backtrack events or actions or any kind of changes that happen, security logs for security, server logs that has to do with specific servers, system logs has to do with the system itself, network logs have to do with the network, database has to do with databases, and web servers have to do with web servers. So these are the types of logs that you'll deal with, and there's a lot of different types of logs in addition to these things. These are just the most relevant to us as we're studying for cybersecurity, right? So these are the various types of logs that you deal with, and these are the reason why they're so important. And this was just a sample log that we looked at. So this, again, I skimmed through it, I burned through this information because I've already done a full video on the introduction to logs, so I'm not gonna spend a lot of time on this. So video, episode 1, episode 2, and episode 2A, or I don't know how I named them, but those 3 specific episodes will give you a really good introduction to this. And now we can actually go into the specific, the more, I guess not specific, but like the deeper details on the log analysis concepts, which is obviously investigation theory, detection engineering, and all the good stuff that comes with this. So let's jump into investigation theory. All right, to investigate, and this is more going to go, I think this applies both to reactive and proactive threat hunting and cybersecurity. But to investigate an incident, you need to look at several things, right? So there's the timeline. The timeline is the beginning and end of the whole thing. So when conducting a log analysis, creating a timeline is a fundamental aspect of understanding the sequence of events, right? So from the beginning to end, within systems, devices, applications, the network, all that stuff. So this is a high level kind of a perspective, and you're looking at the chronological representation of the events ordered based on their occurrence. So from the beginning to the end, this is the timeline of what just happened to this. And to be able to actually see what's going on is very important to give yourself a context, to give you a full picture, a big picture view of what just happened over a specific period of time. And then with incident response scenarios, it plays a very important role in reconstructing security incidents. So when something happened, knowing the timeline gives you an understanding, again, of the full image. It's probably going to be like something that I'm going to hammer on over and over and over again. So the big picture is very important. The full image is important so that you understand the full concept of what just happened. When you have an effective timeline, security analysts can trace the sequence of events leading up to an incident, allowing them to identify the initial point of compromise and understand the attacker's tactics, techniques, and procedures, which is something that you will see a lot when you're studying for the CYSA exam and when you actually take your CYSA exam. So understanding tactics, techniques, and procedures is very, very important. So there's the timeline, and then we have the timestamp. So timestamp is something that is a base requirement for logs. So most logs will typically include a timestamp by default. Sometimes you may have to actually turn it on and make sure it's there. If you don't have a timestamp, you can't create a timeline. You see how that works? So with the potential of many distributed devices, applications, and systems generating individual log events across the regions, it's crucial to consider each log's time zone and format. Converting timestamps to a consistent time zone is necessary. Usually it's universal, so UTC. And it gives you it's a convenient way to do accurate log analysis and correlation, which means combining all of your logs across different log sources. Many log monitoring solutions solve this using time zone detection and automatic configuration. Splunk is one of them, and it automatically detects and processes time zones when data is indexed and researched, regardless of how many times or regardless of how time is specified in individual log events. Timestamps are converted to Unix time, and it's stored in the time field when it's indexed. And the consistent timestamp can be converted to a local time zone during visualization, depending on where the person is, where the analyst is that's looking at it, which makes reporting and analysis more efficient. And it ensures that the analyst can conduct accurate investigations and so on and so forth. Then there's something called a super timeline, which is something that I just learned about. So it's also known as a consolidated timeline. And it's a very powerful concept. Super timelines provide a comprehensive view of events across different systems, devices, and applications, allowing analysts to understand the sequence of events holistically. So across all of the devices that were involved, across all of the applications that were involved, all of the time stamps get combined, and you get a super timeline that gives you the full picture with all the devices, all the elements, and basically the endpoints and everything. It gives you basically everything. So it includes data from previously discussed log sources such as system logs, application, network traffic logs, firewall logs, and more. By combining these disparate sources, that's an interesting word, disparate sources into a single timeline, analysts can identify correlations and patterns that need to be apparent when analyzing logs individually, Creating a consolidated timeline with all this information manually would take time. Not only would you have to record timestamps for every file, but you would also need to understand the data storage methods of every application. And Plazo, the Python log2 timeline, very, very cool, I love Python, is an open source tool created by Kristen Gudjonsson, I hope I pronounced that right, and many contributors that automate the creation of timelines from various log sources. It's specifically designed for digital forensics and log analysis and can parse and process data from a wide range of sources to be unified and chronological. So very, very cool. And Plazo is the official documentation page. Oops, I did not mean to do it in this window. My keyboard timed out and I got sent to instead of opening up a new window, there we go. So welcome to Plazo documentation. So I mean, you can read through this. I'm not going to read through this right now, but there is a plazo.readthedocs.io is what you can find that. Or you can just get yourself a free membership and just go inside this room and get that direct link. Data visualization is what makes this super freaking easy. If you're doing this to the command line, you can still make it easy. Or if you're just doing like a log line by line kind of analysis. But if you use something like Elasticstack, Kibana, or Splunk, you get a visualized format like this. And it's just, dude, it's so much easier. I mean, compare this to literally a black and white screen with line and line and line of code. I mean, who wants, not code, but you know what I mean, like log items. Like who wants to do all that? So what this does is it gives you the event IDs. It gives you the applications themselves. It gives you the processes that were used. It gives you so many things. It'll give you usernames. It'll give you the geolocations of where these things happened, the timeline that it happened, the number of moderate, high risk, or critical, everything. It gives you everything. This is the dashboard itself specifically, and then you click on any of these and you can go dig deeper and go further into the rabbit hole. And it's just, I mean, it's amazing. We call this the single pane of glass, which is the concept behind the dashboard. And you can customize your dashboard to show you the events that you think are more relevant to you, or the data that's more relevant to you, and it just makes your life way, way easier. So to create an effective visualization, you got to first understand the data and the sources that are collected and define clear objectives for what you're trying to visualize. So imagine that you're trying to monitor and detect patterns of increased failed login, and in that case you would want to visualize logs that have to do with login attempts from an authentication server or a user device. A good solution would be to create a line chart that displays the trend of failed login attempts over time. To manage the density of captured data, we can filter the visualization to show the past 7 days. That would give us a good understanding, good starting point to visualize these things. Then you have log monitoring and alerting, which is also another thing that happens with Splunk or Elasticstack, which gives you alerts. They'll monitor all of your logs in one place because you can connect all of your endpoints to Splunk or Elasticstack. And once you have all your endpoints connected, it monitors all of those endpoints. And if something of note happens, you'll get an alert on your screen, especially if you've set up your dashboard to show you those specific things. And events that are worth creating alerts for could be multiple failed login attempts, privilege escalation, access to sensitive files, or other indicators, or trying to access sensitive ports that shouldn't have been accessed, all that stuff. So alert that the security team are promptly notified of suspicious activities that require immediate action. That's what alerts do. The roles and responsibilities would be defined for these things. So for escalation and notification procedures, those would be defined for various stages of the incident response process. So if somebody notices it, they'll probably send it up to their immediate supervisor, which if it's really important, they'll send up to the manager, so on and so forth, and eventually it might even get up to the CISO, right, the Chief Information Security Officer. So there's a hands-on walkthrough for this, for Splunk Dashboards and Reports Room, which I think we've already done. Oh, we haven't done this, but okay. I mean, it's not that big. It's not that big of a deal because it's just the Splunk dashboards and reports, and we're gonna get a really good understanding of it, or at least a good a sample of it, especially when we go into the advanced videos for this particular pathway. But I've done multiple videos on Splunk already, so you can go ahead and check those out to see what the Splunk dashboard looks like, to see what basic events monitoring looks like. I feel like I should have already done this, but okay, it's all good, no big deal. Then we have external search and threat intelligence. So identifying what may be of interest is very important. And first you got to understand what threat intelligence actually is and where you can go find the information like that. So VirusTotal, for example, is a website that has a bunch of different IP addresses, URLs, files, file hashes, all of those things inside of its database. And you can go there to compare an IP address versus their database to see if an IP address is a threat, right? So that's a threat intelligence tool that you can use. And there's the overall concept is pieces of information that can be attributed to a malicious actor, and it could be IP addresses, file hashes, domain names, so on and so forth. So when you analyze a log file, you can search for the presence of these things. For example, this web server log, which is right here, you can see that the IP address has tried to access our site's admin panel, right? So when you look at this whole thing, let's see, so cat access log is the command that shows it to us, and we have these various line items. And so if we were to try to sift and sort through this thing, we can try to see, because they said they try to access the admin room. So let's see if we can actually find that in here. So first one, this is the timestamp, get admin. There you go, get admin, HTTP, and it was successful because 200 is a success message. They used the Mozilla compatible, so on and so forth. Robot file, and then this is another one, get TryHackMe room docker rodeo yada 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 catalog, one PNG, and that seemed to be successful as well. And then get TryHackMe, I don't know what this is. This seems to be an injection that they put inside of the URL to try to get some information. And again, this came out successful for them. And then another request to TryHackMe designs. Again, this was successful, right? So using threat intelligence like ThreatFox, we can search the logs for known malicious actors' presence. So ThreatFox, I'm assuming, is kind of like VirusTotal, right? So if I go here, ThreatFox database, look at that. And then you can go look at this. You can search for a bunch of different things. So search the syntax seen below, example, malware, zloader, and all that stuff. So that is another cool tool, which I did not know about. And so you can search for the malicious actor's presence, and it gives you an IOC is an indicator of compromise. The malware names are here, the tags are attached to them, and the people who reported them are all here as well. So if we search for this IP address inside of the log file, you'll see, I mean, I guess they just searched for that and it just gave them that. So it's not that big of a deal. So it says, what's the term for a consolidated chronological view of logged events from diverse sources, including or often used in log analysis and digital? I would say that is the super timeline, right? Yeah, super timeline. Which threat intelligence indicator would this hash and this hash be classified as? So we're going to copy this, and we're going to go to ThreatFox, and we're going to, let me see if I just paste this, if this will work. No syntax. Let's see. Oh, I see. So I was actually trying to find this specific hash, I guess what these hashes are connected to. I knew that these were hashes, but I think what they're trying to do is they're trying to go over here. So right here it says external research and threat intel. What is the indicator, right? So this is the types of indicators. So IP, So file hashes would be the specific answer that we're going to be looking for. And there we go. Okay, cool. That is all good. All right, so now we can move on to the next one. Damn, this is a long one. Okay, cool. We got detection engineering, which is the current piece right here. All right, so we got common file locations here. So web server log locations on an Nginx web server for access logs would be, and these are all Linux. So this just by itself, you can kind of determine that these are Linux computers or Linux machines that you're looking through. And so they would just have the Nginx would be the directory, and inside of that directory would have your different logs. And same thing with Apache, and so on and so forth. And so databases, MySQL, you'll notice that, you know, Verilog, all that stuff is where it is. And then you have MySQL, Errorlog, and then Verilog, PostgreSQL. So if it was a PostgreSQL database versus MySQL database, same thing. Web applications, Verilog, PHP, Errorlog, syslog, authentication log, IP tables log, Snort, has its own directory, so you can have snort logs, or you can just dedicate it to be in whatever directory that you want, but it just makes it more convenient and easier to track down and transfer to other analysts if you just keep the same directory for the snort logs. So these are common, but it's important to understand that the actual paths could be different based on the system configurations, the software versions, and anything of the sort. So it's recommended to consult the official documentation for this. And then there are common patterns. So common patterns and trends in log data is important for identifying potential threats. These patterns refer to the identifiable artifacts left behind in logs by threat actors or cybersecurity incidents. Fortunately, there are some common patterns that, if learned, will improve your detection abilities and allow you to respond efficiently. Abnormal user behavior is considered to be an anomaly. So one of the primary things that show up is unusual or anomalous user behavior, and this refers to any actions or activity that deviate from the typical or expected behavior, or also known as the baseline. So to effectively detect anomalous behavior, organizations can employ log analysis solutions that incorporate detection engines and machine learning algorithms to establish normal behavior patterns. Deviations from these patterns, or baselines, can then be alerted as potential security incidents. So Splunk user behavior and analytics is one of them, IBM QRadar is another one, and Azure AD identity protection is another one. So Splunk, you already know. IBM QRadar is the SIM for IBM, and then Azure is the Microsoft Cloud environment, and AD is Active Directory. So Azure AD Identity Protection, these are all great solutions to this specific concept of detecting abnormal user behavior. And abnormal user behavior could be anything like this. So multiple failed login attempts, unusual login times. So somebody tries to log in outside of normal business hours, for example, or outside of their regular operational hours, 3 in the morning. It's like, okay, what are you doing trying to log in at 3 in the morning? Geographic anomalies from IP addresses in countries the user doesn't usually have access to. So that's another thing which can be combined with the unusual login time. Frequent password changes. So if a user's password has been changed frequently in a short period, may suggest an attempt to hide unauthorized access or take over an account. And unusual user agent strings. So in the context of HTTP traffic, requests from users with uncommon user agent strings that deviate from their typical browser may indicate automated attacks or malicious activities. For example, by default, the Nmap scanner will log a user agent containing Nmap scripting engine. The Hydra brute forcing tool by default will include Hydra in the user agent, and these indicators can be useful in files. So if you are scanning somebody, basically using Nmap, it's going to say Nmap scripting engine inside of the user agent description. If you use Hydra brute forcing, by default it's going to include Hydra in its user agent. And if you want, on the pen testing side, if you don't want to be detected, you need to change that, right? But by default, it's going to say Hydra, and Hydra is a brute force web application password hacker, right? So the significance can greatly differ or vary greatly depending on the specific context and the systems in place. So it's essential to fine-tune any automated anomaly detection to minimize false positives. Common attack signatures is also another one of those things that, just based on the databases that are available, and a lot of these tools have those databases ingrained in them already. They're embedded already, so they can detect attacks that are happening based on the attack signatures that are going on. So anything like malware, web-based attacks, SQL injection, cross-site scripting, directory traversal, all those things have signatures that are already inside of a bunch of databases. So depending on what you use, it'll show up as that signature. So for example, SQL injection exploits vulnerabilities in a web app that interact with databases, hence the name SQL. So looking for unusual or malformed SQL queries in the application can identify an injection attack. The suspicious queries could contain unexpected characters, like a single quote could be one of those things. Somebody just does a single quote, or somebody tries to do a comment, or one of these things. Union statements, time-based attacks, all of these things are hints that somebody's trying to do some kind of an SQL attack against you. And if you don't know what that means, definitely go and check the pen testing videos that are on the channel, And I want to create a lot more videos around this topic because it's a very interesting topic. But there are videos that we've done SQL attacks, SQL injection attacks, and you can definitely go check those out. We have an SQL injection attempt by doing the single quote followed by union select, and then it's part of the query parameter. And the attacker appears to have escaped the SQL query with a single quote and injected a union select statement to retrieve information from the user's table. So this is the original thing, right? So this is the full thing. Get products PHP, Q books, right? And then you see how there is a double quote right here. So that's the beginner, the beginning part of this entire thing. And so they do the command right here. A single quote will end this, or essentially what it does is it escapes the previous thing, and it does a union, and it then combines it. So selecting nothing and nothing from username, and then getting the passwords nothing from users, right? So excuse me, not from username. So selecting nothing, nothing, username and password, nothing from the user's database, and then doing this piece right here to comment it out and make sure that the rest of it actually goes through, and then they get a 200 success, meaning that they actually were able to pull that information. They were able to get all the usernames and passwords from the user's database. So, or the user's table, I should say, not the user's database, the user's table. Cross-site scripting allows people to inject malicious scripts into the web page. And XSS attacks, it's often helpful to look for something that has script in it because they're trying to insert scripts. So on mouse over, on click, on error, right? A useful XSS payload list to reference can be found here. So let's see what this is. Oh, this is a GitHub repository that has a bunch of different XSS scripts for the intruder. So this is a cool one. This is something that I would recommend that you check for. And these are some of the things that you can do. XSS strike or XS strike, whatever, brood XS, etc., etc., etc. And there are good info there for you to reference. And this is an example right here. So you have, again, the same thing, and then search equals, so get products.php, and then search, and then they inserted this script at the end of it right here. And this basically just puts something onto the screen that says alert. That's not that big of a deal, but they injected a script right here. And that's it. It opens with a script inside of these brackets, and then you have a bracket / script. So just noticing this, you can tell that this is the script. And if you want to see what the script is trying to do, you just find all of the information between these two right here, and you can get a good understanding, or at least you can find the body of the script, and then you can go to some kind of an AI tool and say, hey, what is this script trying to do, right? So path traversal is another one of those things that once they get inside of a web server, they're just trying to get up the web server, traverse up the web server. So when you do CD, and I'll show you this actually because this might be a little bit easier to demonstrate by doing this, right? So if I open up a terminal, and this is my current path right here. All right, so this is going to be my current path, which is the root path. Let me zoom in a little bit for you. Inside of the root path, we have all of these files right here, and some directories. The stuff in the blue is a directory. So if I go into the desktop, there is a bunch of stuff inside of the desktop, and then so there's tools on the desktop, and I can go inside of tools, and then there's a bunch of stuff inside of here, and then I can go to PAS, for example, and now we have a bunch of stuff right here. And now you see that my command line has now changed into this, right? So if I wanted to get back into the root folder, into my main folder, I would do cd .. /.. right? So the first one gets me out of this, the next one gets me out of this, and next one gets me out of this, and gets me all the way back to the root folder. And I just press enter, and now I'm back in the root folder, and you press ls, and now you're inside of the root folder, right? So you can do the same thing inside of a web server by putting it inside of the actual get request of the website, or maybe even inside of the URL at the very top right here, right? So the person that did this right here after the products PHP type of thing, they could probably just do it over there. Like we've done that on server-side request forgeries, where we just put the the dot dot forward slash, the this is not an ellipsis, because ellipsis would be 3 dots, but the dot dot forward slash dot dot forward slash, it just keeps taking you higher up the path until you get inside of the root folder, and then from there you can keep going. So this one is going up what, 2, 3, 4, 5 levels. They're going up 5 levels to try to get to where they are, and then they're going to get the etc password file, because the etc password file shows us all of the etc password. It shows of all of the usernames. It doesn't give you all of the passwords, but it'll give you all the usernames. And then you have, you know, the username Whoopsie, and then you have Pulse, and then you have whatever, Iodine, all these different people, and it tells you what group they belong to. And if we scroll up a little bit, and we'll find the root user, so you see the root user, the daemon user, the system user, all these different users that are here, and it gives you the general information. So you don't get all the information about their passwords, but you do get their actual username information and some other useful stuff about them as well. So these are the various types of attacks that can be done that you could potentially detect while you're going through your logs. So the question here says, what is the default path to view logs regarding HTTP requests on an Nginx server? So the default path would be verilog Nginx, and then I'm going to say, what is that? Would it be http.log? Let's see, do we have the example over here? Let me see if I have it over here. Maybe that would be cool. So let's see if we can go to the cd verilog Nginx. Do we have that? No, we don't have that over here. Okay, I'm just going to take a guess here, and I'll probably do http.log and see if that works. Okay, so http.log is definitely not going to work. So what I'm going to do, I'm just going to Google this actually. And, oh, okay, it's access.log. So we can just go and change this to access. Let me see if that works. There you go. Access.log is the default path for that. Okay, not bad. Easy to find. Now this one says a log entry containing this was identified. What kind of attack does this look like? So let's see. All right, so here's a little trick for you, okay? Based on this, I just know that this information right here, this looks like an URL encoded line of information. So I went to CyberChef, which is one of our favorite tools here. I pasted it inside of the input right here, and then I put URL decode, and automatically it gave me the information. And we have dot 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 proc self environ, which means, just based on the dot dot, so this is a path traversal attack, like that, just like that. Easy money. So there we go. We got some good information on detection engineering. So now let's go into automated and analysis, manual analysis. And I think the very next one, yeah, that's when we're going to start doing some actual exercises here. So that should be fun to do. All right, so automated versus manual analysis. Automated analysis, as you can imagine, involves tools or scripting or something like that. So it could be something like XPLG, SolarWinds, Logly. Automated tools allow for processing and data of analysis of logs, and they often use AI or machine learning to analyze patterns and trends. What can happen is that you can have false positives, right? So the advantage is it saves time, right? The use of artificial intelligence is effective because it recognizes patterns and can do it much faster than a normal human being. But the disadvantage is that they're usually either commercial only, which are expensive, but again, you could just go to ChatGPT and drop in your log file as an attachment, and it could try to analyze it for you, and that's for free. So that part is cool. But the effectiveness is depending on how capable it is, and then false positives right here. So false positives is a big deal. Like it'll just it'll think that, you know, any smoke means that there's fire going on. It'll give meaning to things that don't necessarily have to have meaning, or it'll miss things. So a false negative would be one of those things where it says, oh, this is nothing to worry about, but it actually is something to worry about. So it's good, it has advantages, but it shouldn't replace manual analysis. So manual analysis is it's cheaper because you don't need expensive tools, although that could also be argued, because paying for a security analyst to do something like this, it takes, you have to pay them, so it might take them a lot of time to do it. But simple Linux commands, if you know how to use the Linux command line, you could actually sift and sort through files pretty quickly. I did it in the last video using the command line, and it was really quick. So if you know how to do the command line, whether Windows or Linux, you can sift through log files pretty quickly and try to find the information. But again, you have to do a lot of sifting and sorting through, so it's time consuming. So it's one of those things that the AI could do it so much faster, and the analyst needs to sift and sort through each log file to try to and find them and try to connect all of the dots, right? There's a thorough investigation that's an advantage that there's literally no disadvantage for this specific line item, because I mean, you get to look at everything and you get to put all the dots together, and you're much more thorough than what an AI could be, because the AI is looking for patterns and things like that that already exist, because it's been trained on data that already exists. So if there's a 0-day attack that's been done, which means an attack that has never been used before, then the AI is most likely not going to be able to tell, because it's looking for signatures that already exist in databases and its own data sets, and that's what it's basing its search and analysis on. It reduces the risk of overfitting or false positives on alerts from automated tools. Events or alerts could be missed, right? So this is the other piece, right? If it's a big log file, if there's a lot of information in the log file, the AI is most likely not going to miss something, because it's very, very good. It's going to go line by line through everything. The human being can probably miss it, and that's the part that is one of the big disadvantages of using a human being to go through a lot of log files. Then you have contextual analysis that a human being can do. They have a broader understanding of the organization and cybersecurity landscape, whereas the AI would probably need to be trained for a long time to establish a really good baseline to be able to do that. But the human being can already do that pretty quickly, because they already have the understanding. And there's no disadvantage to that specifically. But the big part of this is that it is very time consuming for a human being to do this. And this side, it's so much faster to do it, but it can give you false positives, false negatives. It could be expensive because you have to buy this expensive tool, so on and so forth. So our question here is: a log file is processed by a tool which returns an output. What form of analysis is this? So it's reviewed by a tool, so it would be automatic. And an analyst, is that wrong? What form of analysis? A log file is processed by a tool which returns an output. What form of analysis is this? Is that wrong? What? How's that wrong? Oh, automated. Oh my god, dude, are you kidding me? Automated, there you go. And an analyst opens the log file and searches for events. What form of analysis is this? That would be manual, and not manula, manual. Very good. All right, cool. We are now done with this, and now we can go into our specific tool right here. So very cool. All right, cool. So the first one that we're going to be dealing with is the Apache log that is inside of this room already. If you're going to be using your own Linux machine to connect via VPN to the servers at TryHackMe, you can download these task files. But for us, they already have it over here. So I'm just going to go to this specific directory, and I'm going to find that Apache log. And then we're just going to run our commands right here so we can find this information. And we'll probably be able to answer some questions at the very bottom using these pieces of info, right? So it says use cut on the Apache log file to return only the URLs. What is the flag that is returned in one of the unique entries? And in the log, find how many total HTTP 200 responses were logged, so we got to count that. Which IP addresses generated the most traffic, we got to find that. And what is the complete timestamp of the entry where this thing accessed login.php. So I'm going to keep all of those things in mind, and as we go through all of these commands, we'll find those answers. So at the very, very top here, the first command that we're going to do is cat, which basically means concatenate. And it's going to list everything that is inside of that log. So first, let me just go into the directory that has it, intro log analysis task 6. And there we go. And so if I do ls, there's only one log in here. So if I just do cat apache.log, we'll see that we have the full thing, right? We have the full output of the log file, and there's so much that it literally, I mean, this would be a lot to just sift and sort through, and it can be intimidating, right? This is a lot. This is a lot of information, and I don't want to sit here line by line reading through that whole thing. So the first command that we can do is you do less apache.log, and when you do this, it displays the first page by default, and then you can just scroll down using the arrow keys or with page up and page down, and it'll give you the next page and then the next page. So it makes it a little bit easier to read instead of kind of scrolling through a bunch of data like this. So if I just did less apache.log, now you see that it gives me this thing right here, and it's just one page. You see it won't like scroll up and down or anything like that. So I can just do, or actually I think when I scroll it does do that. So if I just do page up like that, it'll take me through all the data that was previously there. And so this is the very top. So this is the first set of data, then this is the next one, then this is the next one, then this is the next one, so on and so forth. So there you go. I think it's kind of registering late, but you get the idea, right? So for each page, because you see that this doesn't, like, there is no space for the scroll bar to go, so it means that just on this specific screen I'm getting a certain number of output, and then if I just do this, it'll get me the next set of output, and so on and so forth. So that's what less does, right? It gives it to you one page at a time. Now tail, what it's going to do is going to give you the end of the file, and it typically gives you the 10 results at the very end of the file, and it's typically coupled with the F option, which allows you to follow the log file in real time because it's continually updating the terminal window new log entries as they're generated. So this is very useful when you're doing live events, but in our particular situation, I don't think this is a live event. I think it's just a pre-established log that they gave us. So it's going to only show us the last 10 lines of the file, and we can change this with the N option to only give us the certain number of files. So in this case, it's only going to give us 5 lines, right? So this is going to be live 5 lines from the Apache log. So I'm going to go ahead and do that now. So if I do Q, or if I do, what is it, escape or Q? How do we get out of this? I'll do Control C. I think it was probably Q actually. So we're going to clear the screen here, and I'm going to do tail F N5, and I'm going to do Apache log, and there we go. And now it's going to give me 5 lines, right? Very easy. But I don't think this is being updated in real time, so I don't think that these 5 lines are going to change or be updated in any way. But it's a good habit to just have the F as a part of your tail command, so it's just constantly giving you the most recent ones. It's following the path of this log file, and it just keeps giving you the most recent inquiries or the most recent line items that come through the log. So tail F N5 Apache log, and that's what we got. And now there's a little note right here that says the opposite of tail is head. Head gives you the top of the file, so the first 10 lines, and same thing, right? So you can get the first 10 lines or the first 5 lines or the first whatever from a file. The tail gives you the most recent events that are coming in place, because when you look at the file, the top of the file is the very beginning of the events, and the bottom of the file is the most recent, the latest events that happened. So typically tail, I feel like, would be better if you're trying to find recent events, right? Or if you're just trying to get to the end of the file and find especially if it's like a giant file, or if it's a giant file and you're trying to get to the top of the file but the terminal doesn't show it to you. Sometimes it does that. This time it didn't do that because I was able to see the very top of the file, but sometimes the file is so big that no matter how high I scroll inside of this thing, it won't show me the very top of the file. It just stops at a certain point, and that ends up being something that is very inconvenient, especially if you're trying to find what happened at the very beginning. So then we got something called word count. The WC command is a very important thing, and it doesn't give you any other result other than the word count, right? So after running this, you can determine that the file contains 70 lines with 1562 individual words separated by white spaces and 14,000 individual characters. So these are the words, these aren't characters. And then there's 14,000 individual characters. So let's compare it to see if this is actually what we got based on this thing. So let me get that out. So if I do wc apache.log, it'll actually exactly the same, right? So 70, 1562, 14305. Is it 14305 here? Yeah, 14305 here too. So exactly the same input. So they're looking exactly at the same file here. So now we're going to look at the cut command. So it extracts specific columns or fields from the file based on specified delimiters. And this is very handy if you're working with log files that have structured or tab separated data. If it's not structured, it's probably useless. It's not going to work. So if we want to extract all of the IP addresses in the file, we can do cut to specify a delimiter of a space and only select the first field that's been returned. So what's important is for us to understand what actually is at the very, very top of the file, so we can kind of see what this whole thing does. So if I do head, I'll just do head and I'll leave it at the 10 lines, and I'll do apache.log. Hopefully it'll actually show us the very, very top of the file, and we can see, no, it doesn't give us that. So it doesn't give us the field names, but what we can see just from the pattern of the information that's here is that the first item is the IP address, the next item is going to be the timestamp, and then the next item is going to be whatever command they were sending, and then you have the result code that was given to us, and you have the user agent, and this is the actual event ID probably, so on and so forth, right? So if I wanted to pull all the IP addresses, I would just look at the very first line item, which is exactly what they did over here. So cut D, and the delimiter is going to be a space, in this particular case field number 1 from the Apache log. So I'm going to go here, I'm going to do cut D. Oh man, my computer is tripping right now. I think it's the connection to this virtual machine. So if I do cut, there we go, D, we'll do a space as the delimiter, and we're going to do field number 1, and then we're going to do apache.log, and give me an enter. Okay, cool, there we go. And we got all of the IP addresses that were cut from this entire thing right here. And then you can combine this with probably the next thing that they're going to tell us about, which is sort. There you go. Sort, and then there's another one that should be unique. And then there should be sed for log analysis. Let me see, is there a count? Should be count in here somewhere. I wonder if we're going to do it. Okay, so never mind. So we're going to do, what is it? The next one is going to be sort, which is going to take it from the smallest to the largest, I think. So sometimes it's helpful to sort the return entries chronologically or alphabetically. The sort command arranges data in files ascending or descending based on the specific criteria. It's very crucial for identifying trends. It's also common to combine the output of it or output of another command, so for example cut, and then use it as the input using pipe. So when you use pipe, this thing right here, it takes the output of this command and then it sends the output of this as the input of this, right? So you take the output of this command and you send it as an input into sort, and it'll now sort it. You see how it shows you everything in perfect order. So if I do cut, and then I'm just gonna literally press up in my tab right here, and then I'm just gonna pipe that result into sort, and we're gonna do in this particular case, and it's going to sort these things numerically for us. And so we see right here, let me just kind of extend this a little bit for us, and we see that we have all of these IP addresses that are here, and they've all been sorted numerically from the smallest to the largest. So 76.89 is going to be smaller than 104.76, right? So 104 is greater than 77 or 99, right? That's how this thing works. And then 110 is greater than that, right? So you see how it's going ascending order, and it gets to the 200s, so on and so forth. And there is a question at the bottom right here that's telling us, it says use cut to return only the URLs. What is the flag that is returned in one of the URL entries? Then in Apache, how many total HTTP 200 responses were logged, and then in Apache, which IP addresses generated the most traffic, and so on and so forth. So it's not going to be on the IP addresses, but we do want to return the URLs specifically. So what I'm going to do one more time is I'm going to do head, and I'm going to read the Apache log file one more time, just so I can find out what field the IP address is in. And in this case, I believe, because this seems like an empty field, so I don't know if this is, we're going to count this as 1. So this will be 1, this will be 2, this will be 3, this will be 4, from what I can tell. Yeah, so this will be 4. And then this is going to be 5, that'll be 6, and this is going to be 7, which will be the last thing. So number 4 will probably end up being our pool of the IP address. So now what we're going to do is we're going to do the previous command, and we're going to search for field number 4. And what's the question one more time? It says, what is the flag that is returned in one of the unique entries? So only return the URLs and look for a flag that is inside the unique entries. So we need to combine cut, we need to look at 4, and then we need to find the unique entries, which is where this comes into right here. So this is the last piece, or not the last piece, but this is the very next piece right here. So you look at cut, delimiter space, field number 1, we're going to do field number 4, and then we're going to sort it numerically. And R in this particular case, let's see what R stands for. Okay, so here we go. So we have sort n, so it gives it to us numerically. And then you have R that can be the reverse version of this. So instead of doing numerically ascending, it'll be numerically descending. So it reverses the order, it gives you the large one first. And then there's another one that comes down with this, which is the unique, right? So you have the same cut command, then you have sort nr, and then you have unique, and it gives you all of the unique IP addresses that showed up. And then you do unique C, and it'll count the number of times that these IP addresses showed up, right? So this is going to be something that's going to be right here, because it says how many total HTTP 200 responses were logged, which is going to be this field right here that has all the 200 responses in here. And then it says only return the URLs. What is the flag that is returned on one of the unique entries? So let's try to find that one here. So we're going to use our unique information right here. So first I'm going to do cut, then I'm going to do D, and we're going to separate it by delimiters, and it's going to be field number 4, which I believe is the field that has all of the domain names, or the URLs that are being pulled. And we're going to pipe that into our sort command, and sort doesn't need to do it numerically because they're not numeric, right? So we're going to sort it, and we're just going to do unique, and I'll even do count to see what shows up. And okay, so number 4 is definitely not the URL. Number 4 is giving me the date. So if this is number 4 and it ends right here, so this could be number 5. Oh, I see. So this is going by the delimiter, which is space, right? So this is 1 space, this will be 2 space, this will be 3 space. So this will be item number 4, and then that'll be another space. So this will be number 5, that'll be another space, and that'll be number 6, and that's another space, and that'll be number 7. So it's actually going to be number 7 because we're using the space as the delimiter. So we're going to go back here, and we're actually going to go all the way back here, and we're going to do space number 7, and that should give us all of our IPs. Look at that. Okay, cool. So there we go. And so this is the flag right here. Flag equals yada yada yada. So we're going to copy that, and I'm going to come down here, and I'm going to paste this mofo in here, and voila. Great. So in the Apache log file, how many HTTP 200 responses were logged? So field number 7 gave us that, which means after that space is going to be HTTP, so this will be field number 8, and then we have another space, and this will be field number 9. So the responses are going to be field number 9. So I'm just going to do exactly the same thing here, and we're going to go sort, and then we're going to do field number 9, press enter, and you got 52 200 responses, and you got 19 404 responses. So 52, voila. And which IP address generated the most traffic? So that's going to be field number 1. And let's go, and we're just going to mess with the same exact thing now, and we're just going to do field number 1. Press enter, and you got all of these things. And let me see which one gave us the most. So we have 6 here, we have 6 here, 6. This one is 8, so that's the highest one so far. And yeah, I think the one that has 8. So 8 is the one that has the highest count. So we're going to copy this thing right here and go boom. There we go. And what is the complete timestamp of the entry when accessed login.php? So this one, I'm going to try to see if there's other information that we can find over here, which I think is going to be actually using probably grep and some of the other stuff right here, because I got a little bit, I mean, we got a lot of information just learning how to use unique and sort. So that was very, very useful. I love this stuff. Like, this makes it so freaking cool for me. So okay, so now we have SED, S-E-D, and AWK, which I think is the next one right here. So SED and AWK are powerful text processing tools commonly used for log analysis. They are sometimes used interchangeably, but both commands have their use cases and can allow security analysts to manipulate, extract, and transform data efficiently. So using the substitute syntax SED can replace specific patterns or strings into log entries. For example, to replace all occurrences of this with July this in the Apache log, we can do this. You can do SED. Oh, I see. And so this is a regex type of a situation. And then now it's going to replace all of these instances with July 31. And so there you go. You see July 31, 2023, so on and so forth. That's pretty crazy. So notice the backslash character is required to escape the forward slash in our pattern, and tell SED to treat the forward slash as a literal character. Also note that it does not change the log file directly. Instead, it only outputs the modified version of the file into the command line. So for example, if you want to overwrite the file, you can add the -i option to edit the file in place, or use a redirect operator to save the output of the original file. If you use this, it's going to risk overwriting the original data, so just be careful. And then the awk command is a common use case, and it's conditional based on the specific field value. So for example, to print log entries where the HTTP response code is greater than or equal to 400, we can use the following, right? So anything greater than 400 would be an error status. So if you do awk field 9, because field 9 is where we had all of the response codes, is greater than or equal to 400, it'll only show you 404, what's this one right here, 404, so on and so forth, 404. So it only shows those, right? In this case, we're using the number 9, the $9, which is the log example for HTTP status codes, requiring that it's greater than or equal to 400. And now you have grep, which is a search tool that you can use it to search through files. So you grep admin apache.log, and it'll show you everything that has to do with admin. So as long as the word admin is in here somewhere, look at that, admin is in there somewhere, and it can do it. So if you do unique count, so grep admin apache.log with count, which it doesn't show right here. Oh, actually, no, I'm sorry, it's right here. So count. So you can do count with grep. So instead of it showing you the actual result, it'll just count the number of times that admin has showed up inside of this thing. And if you wanted to know which line number the log file relates to this, you can do grep n admin, and it'll give you the line number that this is attached to as well, which is at the very beginning right here. So on line 37, this is the thing that gives you admin inside of it. And then you can invert the command using the V option only to select the lines that don't contain a pattern or keyword. So for example, if you want to show everything that doesn't include index.php, then you do that, and then you can grep this from it, right? So you grep inverted this apache.log, and then from all of those results, I want you to grep this specific IP address, which is probably what we're going to end up using to find our final answer right here. So it says, what is the complete timestamp of the entry where 110 accessed login.php, right? So let's do this in totality. So what we're going to do is we're going to grep for login.php, and we're going to do it from the apache.log file, and we're going to pipe that into another grep command that's going to search for 110.122.65.76 and see what we get. And you get one result only. And if we really wanted to be fancy with it, we can even cut the field from it. So this is the IP address, so that's field number 1, space, field number 2, space, field number 3, space. This would be field number 4, right? So if I do, I'm gonna do, what do? I do cut, and I'm gonna do the delimiter is gonna be spaces, and it's gonna be field number 4. I think that's what it was, right? Field number 1, 2, 3, 4. Yeah. So field number 4, and it's going to be from apache.log, and then we're going to grep /login dot, or maybe I should be doing this backwards. Let's try it. Let's see what it works. Login.php. Let me see if that works. It doesn't work, so that's not going to work. So first I'm going to do grep login. I'll actually do this whole thing. So boom, do the full thing, and then we're gonna go ahead and cut that using the delimiter of spaces, and it's gonna be field number 4, and let me see if that brings it. Boom, it got it. Nice. That is super cool. So I'm just gonna take that full thing, and we're gonna copy that, we're gonna paste that, and that should be good. Oh no, so what am I missing here? So let's see. Oh, I need the full thing. So F4, it needs to be everything at the end right here too. So I wonder how we can do that actually. Maybe it could be 4 and 5. So let's see. If we do F4 space or comma 5, fields are numbered from 1 to cut. Okay, I see. So yeah, I guess you can't do that full separator. I would need to find a different type of delimiter, I guess, to be able to make that happen. But there is our answer. Sweet. That was cool. That was fun to do. I hope you learned a lot from that. That was really fun to do. I'm very excited about that. All right, so now we're gonna go through regular expressions. This is a little tough one because regular expressions for me is not super easy to do. It's not super comfortable to do. So we are going to now use regular expressions in our grepping, in our searching. Alright, so regular expressions, also known as regex, are actually really important. They're very, very useful for searching, matching, manipulating data. As you saw the example that we did with the date, or I mean, I didn't do it, but that is a version of regex. That // thing is a version of this. So they're widely used in log analysis to extract relevant information, filter data, identify patterns, which is really big deal. So it's like, I want you to send me something that looks like this pattern, and process logs before they're forwarded to centralized SIM systems. It's even possible to use this with the grep command because it's a really great way to search for patterns. So what we're going to do is we're going to use this specific log file that's inside task 7 and ensure the unzip to unzip the file by running unzip regex.zip, and then go into the regex. Okay, good to know. And then we're going to start grepping through things. So let me traverse up 1. You see, we talked about traversal. See that? So traverse up 1. Now we're inside log analysis. We can do this, and then we have task 7. So we're going to do cd task 7, and we're inside of this, and there's a zip file that we get to unzip. So we're going to do unzip regex unzip, and then boom, like that, and now we have that. And now we're going to go into the cd of regex, and now we're inside of this thing. And now inside of this we have 2 files. We have the Apache, and then we have the email file. So in this particular case, what we've done is we've grepped this specific regex pattern from the log file, and it shows us everything that, I guess, let me see. Let's see what it says. So it says we added the E option to signify that we are searching on a pattern that rather than just a string. So we're searching for a pattern. That's what the E option does. It allows us to do regex. For the pattern itself, we match the literal characters post equals, after which we included the number 1 followed by the dynamic insertion of 0 to 9, including this. Putting this together means 1 bracket 0 9 bracket, which will match any 2-digit number that starts with 1, such as 10, 11, 12, and onward. So if we go over here, let's see what it does. What does it show us? So oh, I see. So it says post 19, post 17, post 13, right? So it's searching for literally post equals 1, and then this is where the regex portion comes in, and it searches for anything from 0 to 9. So it'll give you post 12, post 11, etc., etc. Putting this together, it'll match that, and regular expressions for log parsing. So you can use this obviously for log parsing, and you can create custom regex patterns tailored to specific logs to map something so that's available for a SIM system. So consider the following raw unstructured data, which is this thing right here. And so you have the IP address, the timestamp, HTTP method, the URL, the user agent, so on and so forth. So regexer is an online tool to help teach, build, and test regular expression patterns. This is actually really freaking useful. I'm definitely going to use that. This is the website right here. So very cool. I am super excited about this. I'm definitely going to use that. So it helps you teach, build, and test regular expression patterns. To follow along, copy the above log entry and paste it into the text section of the tool. So I'm going to take this, and we're going to copy this, and we're going to go here. And this is the text section, I'm guessing, right? Okay. Was that it? Yeah, because that's the expression up here. So this is the text section. Do I press enter? No? Alright, so we pasted it. It looks like this. As a basic example, if we want to extract just the remote IP address from this log, we can think about the structure of the IP address logically. The IP address is the log entry's first part, consisting of 4 octets separated by periods. We can use the following pattern: \B 0 to 9. Oh my gosh, see, this is where it becomes like, oh my gosh. So this whole thing right here is one piece, and then this is another thing. Alright, so paste this pattern into the expression field in the regex, and you'll notice that the IP address from the log is successfully extracted and highlighted. Yeah, this is something that I definitely have to study, because regular expressions is not my strength. So I'm gonna go here, and alright, so just like that, the pattern is highlighted right here. So this was the pattern, and we used this pattern, and we got this specific thing. Okay, alright, that worked. So breaking the pattern down, it begins and ends with a word boundary anchor. To ensure that we match complete IP addresses, in between we define the following. So you have 0 to 9 in brackets, and then you have 1, comma 3 for inside the squiggly brackets. So it says match 1 to 3 digits to match numbers from 0 to 999, while IPv4 addresses cannot exceed 255. This simplified pattern works for our use case. Then the / dot escapes and matches a literal dot in the IP address, and then bracket 3, which is the third piece right here. So we got all of this, and then you got bracket 3 specifies that the previous capturing group, which was this full thing that we had, should be repeated 3 times. Okay, and then you have 0 to 9 in brackets again, and 1 to 3 again, and this matches numbers from 1 to 9, completing the 4th octet of the IP address. Okay, so example, Logstash and Grok. Grok is Grok, isn't that like the AI from Tesla? I thought it was. Okay, so Grok is a powerful Logstash plugin that, or maybe it's Gronk. Yeah, it's probably Gronk. Grok is a powerful Logstash plugin that enables you to parse unstructured log data into something structured and searchable. It's commonly used for any log format written for humans to read rather than for computer consumption. It works by combining text patterns with the syntax semantic pattern. However, sometimes Logstash lacks the built-in pattern that we need. In these cases, we can define custom patterns using oniguruma syntax and take advantage of regular expressions. More info on Grok is available on their Elastic documentation here, which is the Grok filter plugin, blah, 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 blah. We might need to refer to this, so I'm going to leave that open. We can use the pattern we previously created to successfully extract IPv4 addresses from our log file and process them into a custom field before they are sent to a SIM. In an Elastic Stack scenario, we can add a filter using Grok within our Logstash configuration to achieve this. So this is the input, I guess, and this would be the filter. And it says filter. This seems like kind of like a JSON type of a syntax. So filter, squiggly bracket, Grok, squiggly bracket, match that the message equals IPv4 address, and then you give it the specific regex pattern right here, and then close, 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 and then you have the output. So we use our previously defined regular expression pattern to extract IPv4 addresses from the message field of the incoming log. The extracted values will be added under the custom IPv4 address. Typically, IP addresses are extracted automatically by default configurations, but this example shows the power of regular expression patterns when dealing with complex log files and custom fields. The Logstash room and the official Grok documentation are fantastic resources for further exploring Logstash. And Logstash room, I'm assuming, is something inside of TryHackMe, which it is, and I definitely have not done this before, so that's going to be something that we'll look at later. So now alright, so it says, how would you modify the original grep pattern above to match blog posts with an ID between 22 to 26? So it's this specific pattern right here, which is at the very, very top. Where is it? So we got post number right here. So 22 to 26. And we need to modify this thing right here. So how would you do this? So it would be 2, and then it would be 2 to 6 right here. So I would take this whole thing. I don't know if I need the quotes over there. We'll see if we need it. I'll take this whole thing, and then I'll do 2 to 6, and then this will be a 2. So it's going to go from 22 to 26. Yeah, nice. All right, so what is the name of the filter plugin used in Logstash to parse unstructured data? And that is Grok. Okay, I mean, they didn't ask us to create a bunch of regular expressions, although I feel like that's going to be really useful. So I'm not going to spend time in this video to do it, but I really do recommend that we learn it together. You know what I mean? I'm going to try to learn it, you're going to try to learn it, and I really think it's going to be super useful, especially when you're going through these types of things. This is just, I mean, that was, yeah, I think it's super useful. That's all I'm going to say about that. It's going to be very, very useful. So all right, now let's look at CyberChef, which we've used multiple times already. I already have it open in a tab even. So CyberChef is super freaking powerful. I love this freaking tool. It makes life so much easier, and you can dump a bunch of stuff in here. Base 64 coding, which is, it looks like gibberish to me, but it'll just decode base 64 for you. So let's talk about CyberChef. Super excited. Alright, so CyberChef is a very powerful tool in the toolkit. It is amazing. It's known as the Cyber Swiss Army knife, and it does a bunch of things. So it has over 300 operations, and it can encode and decode data, encryption and hashing algorithms, data analysis like parsing log files and extracting data, and just a bunch of other stuff. So we are going to, I mean, I already have it open in my browser, so I'm not going to do it inside of the attack box browser. If you're a free user on the attack box, a local copy is installed and can be accessed using the offline CyberChef on Firefox. So, I mean, I already have it in my browser, so that part of it is not a big deal. So the operations tab allows you to select what you want to do with the input. The recipe is the overall thing right here, which you can just dump a few of these operations in here if you wanted to. Input is what you want to be processed, and then output is what the output is going to be, where the result is going to be. The demonstration right here is that you take from base 64. So if you want to take something from base 64 encoding, you dump it in here, and then it sends out the output in plain text, which is in this situation TryHackMe, right? So this is the base 64 encoding, which literally looks like gibberish, and then you have the output, which is TryHackMe, right? So very, very awesome and powerful tool that can do that. So if you want to now encode it, right, so you can literally do or actually, I'm sorry, this is super useful. So if you don't know what encoding the input is, you can just use the magic operation, and it takes its best guess, right? So if you don't know if it's base 64 in this case, right, you literally just do the magic operation and you drop it, and it'll just do kind of like, oh, this is what I think it is, and it'll give you an output, which, I mean, it's so freaking useful. I can't explain how useful this shit is, right? So regex with CyberChef, look at this. This is amazing. So regular expression recipe can be done right here, and you can punch in, I guess I think you would have to type in the reg expression. So we're using this pattern right here, which was for the IP address, to search for values that are IP addresses, right? So you do a user refined regex, and then you type in your regex. I think it can probably even, so let me actually just go here instead of talking smack or whatever. Can I get rid of it? Yeah, I can. So I'm gonna go here, I'm gonna do regular expression, there we go, and we're gonna drop it here, and it says user defined IPv4. Oh, there you go. So if I just do this, it gives me the regular expression for IPv4 addresses. Look at that. If I do IPv6, it'll do a regular expression for IPv6. Very cool. Email address, this is the regular expression for, so look at that, that looks insane. The regular expression for pulling an email address, the regular expression for pulling a domain, MAC address. Very, very freaking cool. And so you could also just do a user defined regex pattern. So in this particular case, we can just take this thing, which would be our version of the IP address search, and then we would paste in whatever the data is, and then from there it would give us all of the IP addresses from that data. And right here it says, let me zoom in here a little bit. It says the output format, so you could have a list, could have a highlight, or you could have captured groups, so on and so forth. So in this particular case, it was a list. So instead of just giving you the same output, or it'll give you all the same data, just highlights the stuff, it actually just gave you a list of the information, which I think is probably more useful anyway. So this is it. And then uploading files into CyberChef. Oh my god, that is so freaking useful. So this is why they probably told us to do it inside of the browser here. I see. So we're going to go through this. We're going to extract the file that's inside of task 8. Then we're going to upload the file into CyberChef, and then use it to list all the IP addresses, and then use the same log file to request that's encoded in base 64. So what's the decoded value of that? And then using CyberChef, decode the file name, encoded flag, and use the regex extract MAC address. What is the extracted value? Okay, so first and foremost, as we know, we're going to go back one. We are going to go into task 8, right? So cd, no, I got to go back one more, and then now I'm going to go into task 8, and then ls, we're going to unzip the log analysis zip file, and that'll happen. And then we're going to go into cd log analysis. Oh, interesting. So instead of I see. So it didn't give me another directory. It just gave me the files. So there it is. So you have access log and you have the encoded flag. All right. So now I know that I have this, and I am going to open up my browser, and then I'm going to go into CyberChef, because they said that it's already included here, and it's an offline version. So we just got to wait for that to load real quick, and click on the little thing. It says offline CyberChef right here. So we're going to click on that. It'll take us to the offline version of CyberChef that's on our local machine here. I'm just going to open this up to make it a little bit easier for us to navigate. And we'll maximize this window. And so the input is going to be for us to add a file. So open file as input. Here we go. And I need to go into desktop, and it's going to be inside of tools, and it's going to be inside of, no, not tools, I'm sorry, it's going to be inside of rooms. There we go. Inside of rooms, and then we're going to do intro to log analysis, task 8, and then we're going to take our access log as our first log, and there we go, and we got a bunch of stuff right here. So let me kind of do this a little bit so we can make some movements, some easy movements. There we go. This is the recipe. Bring this here. Okay, so the first thing that we want to find is use regex to list all the IP addresses. What is the full IP address beginning in 212? So first I'm going to look for regular expressions, and there we go. I'm going to paste that here, and it already has the thing for IPv4, so I'm just going to do IPv4, and instead of highlight I want to do list all the matches, and there we go. So we got all of the IP addresses right here. So what we want to do is we want to find the one that is 212. So it starts with 212. And there it is. So I can only imagine that this is the only one. I hope this is the only one. So there we go. We copied that, and we're going to go back here, and we're going to paste this here, and that's it. All right, cool. So we got that. Then we got the next one where it says use the same file, and a request was made that was encoded in base 64. What is the decoded value? So inside of this thing, there's a request that was made that was in base 64. So I'm going to go here, and I'm going to do base 64. So from base 60, I'll just do base 64 like that. So from base 64, right, from base 64, and I want you to give me something, and it's giving me a bunch of jargon here because a lot of these things aren't even legible, and I need to find the request that was made. Okay, so here is what I was able to find. So first and foremost, I figured that if we just used, so I'm gonna turn this off real quick, if we just use the base 64 thing, which you will see real quick. I mean, you already saw, so I'm just gonna show it to you again. But if we just use that, I deactivated this thing. If we only use this thing, you see that everything over here is jargon, like it's gibberish. You don't notice what's going on. So if I turn this off and turn on the regular expressions filter that I found, and I literally went to Gemini and I was like, hey, I want you to just help me create this thing. I'm looking for some kind of a request, so either a get request or a post request is what I'm trying to filter for, and I want you to try to help me find basically all of the get and post requests. And I did exactly that, and then now it gives me all of these get and post requests, right? So if we go through these requests right here, we actually get to see something that's very interesting. So there is something right here that, you know, just based on my eyes, because I'm a little bit trained to look at these things, this piece right here looks very much like a base 64 piece of code, right? It's mostly gibberish compared to all the other lines that's going on here. It's the one that is closest to base 64 in my eyes, right? So this is a query. This could potentially be it, but I don't think it is because it has the PHP thing at the end of it. And so for me, in my mind, I think that's the one that is going to be our winner. So what I'm going to do is I'm going to do this, and I'm going to paste that in here. And now what we're going to do is we're going to turn on the base 64, and we're going to turn this thing off. And voila, there we go. We got it. So this is the flag that we wanted to collect here. And now I can take this, copy this, and go into our tab here and paste it. And that should be, where am I? It's right here. So now we're going to go paste this here, and that should be our flag. Excellent. Okay, great. So now finally we can go and decode the file named encoded flag and use the regex to extract by MAC address, which should be fairly simple to do. So I'm going to go here and add another file, which is our encoded flag, and then we're going to turn the base 64 off. We're going to go back to regular expressions and turn it back on, and then we're going to do MAC address, which is this thing right here, and then we want to bake it, so bake it for MAC address. Okay, so the way that this one worked was instead of having base 64 be the bottom recipe, we had to put base 64 at the top, because this is all base 64 encoded, and it's supposedly, I think it's just a list of MAC addresses, supposedly, I'm not exactly sure. But if you have base64 as your top recipe, and then after it does decoding from base64, and then you put the regular expression recipe here that has MAC address in it, it'll now give us this MAC address. So we now have that, and we can go here, and we can go here, and we can paste this here, and boom. Okay, cool, we got it. All right, so finally we have log analysis tools known as Yara and Yara rules and Sigma. So let's check these out, and we will be done with this room. All right, Sigma is a open source tool that describes log events in structured format. It can be used to find entries in log files using pattern matching. It's used to detect events, create SIM searches, identify threats, and it uses YAML syntax. What we're going to do in this task is demonstrate being used to detect failed logins in SSH. So writing a Sigma rule is out of scope for this, so we're not going to actually break it down. But basically, this is what it looks like, right? So you have the title for the rule, the description of what it does, the status, the author, and the log source is going to be Linux and SSHD. And the detection, this is kind of, I believe this is pretty much the full portion of the rule right here. So it's going to go through the selections, find this. This is speculating at this point. So the title is the value. This is the outline purpose of the Sigma rule. This provides the description of what it does. This is the this key explains the status of the rule. For example, experimental means that it needs further testing. This is the person who wrote it, where the log files that contain the data that we're looking for are going to be found, which is the log source. And SSHD is the detection. So the key lists what Sigma rule is looking to find. And A0 contains failed. In this case, it looks for all entries that have failed. And then A1 contains illegal. It looks for all entries with illegal. So it has both of these search parameters in here. And under false positives, users forgetting mistyping their credentials, this lists where this entry may be present, but doesn't necessarily indicate malicious behavior. This can be now used in SIM platforms to identify events in the process logs. If you want to learn more about Sigma, you got to go look at the Sigma room, which I got to do. I haven't done. Yara, I've done a video. I think I've done 2 videos on Yara rules. So I'm a little bit more familiar with this. And this is another pattern matching tool, and it's YAML formatted, and it identifies information based on binary and textual patterns like hexadecimal and strings. It's mostly used in malware analysis. That's actually what we did the videos on. But it's very good for log analysis, and this example finds the IP finder. So this is called the rule, which is the IP finder, and it uses regular expressions to search for any IPv4 addresses. And if the log file that we're analyzing contains it, Yara is going to flag it. So this is the rule, which is the IP finder, and you do a squiggly bracket, the meta, which is just the meta description and the meta tags and stuff like that. The strings is what it's going to be looking for, and the condition itself is IP. So the rule itself, that's the name of it. The meta is just the metadata, and then the string itself, this key contains the values that Yara should look for. In this case, it's looking for the regular expression for IPv4, and if the variable IP is detected, so that's the condition, right? So this is the string, and this is the condition that's going to raise this rule. So if the variable IP is detected, then the rule should be triggered. And if you actually go and want to use it, you would end up doing this inside of your command line. So you're going to say, Yara, I want you to use this specific YAR file against this text file, and then it's going to give you your results. So it can look for multiple IP addresses based on a range, IP addresses in hexadecimal. If an IP address lists more than a certain amount, any combined with other rules. For example, if an IP address visits a specific page, and there's a lot more on this. And I pretty sure have done the Yara room. Yeah, I have done this. So there is definitely a video on Yara, I think at least one, but for sure, or I know for sure that there is one, but I think there's 2 videos that you can go check out. So Sigma uses YAML. What keyword is used to denote the title of a Sigma rule right here? in this particular case is going to be what, title. So this this title outlines the so key, or I'm gonna say title. I don't understand why it would be anything else. Yeah, title. That was weird. What keyword is used to denote the name of the rule in Yara? And it's going to be rule. So rule is the keyword for that. And there we go. That one was easy and straightforward. But these are useful. I mean, we're getting into the weeds of these rules, and I think it's very, very important for us to learn how to decipher log files or parse through log files, and all of these things are just super useful. Honestly, I've never used CyberChef to break down regular expressions and things like that, and that part of it was extremely useful to me. So I'm very, very excited about kind of looking at CyberChef in a new way, and this was just very, very helpful to me. So as it says right here, we need to go into Advanced Splunk and Advanced ELK, which is the very next series of modules that we're going to be doing. So we are officially done with our log analysis module, and I'm super excited about it. So we got some good content out of this thing, and the very next series inside of our SOC Level 2 pathway is going to be the Advanced Splunk stuff. So excited for it. I hope you guys got a lot of value out of this one. Alright, if you got value out of this video, or if you've gotten value out of this channel in any capacity, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And I welcome you to go ahead and drop a comment. Oh, there's a new comment that came in literally 57 seconds ago. Bro is cooking in his channel, and I just found out about it. I'm so excited about these freaking comments that come in. It lights up my energy. You have no idea. But the comment section is super lit, man. I'm telling you, there's a lot of good stuff that comes through here, and there's a lot of questions that come through here that I give really long answers to. So this is not something that I take lightly, you know what I mean? This was actually one that came recently. So he goes, can you tell me if I apply for a job after completing this, what will happen? And I gave him a full answer right here. So I gave him like a detailed answer, and I do that for everybody. If you ask a good question, I'll make a video out of it, but if nothing else, I'll drop like a really decent response to your comment to just make sure that you get as much value as possible, because I really genuinely appreciate this community, and I love everybody that comes through here. And as as an extension of that, I would very much love it if you actually joined us in this community as well. So it would be very cool to have you. And I mean, just to kind of make this a little bit more fun, when we get to 100,000 subscribers, I'm going to reveal my actual identity, or at the very least, I'm going to show my face. How about that? Well, when we get to that point, I'll show my face so you guys can see who I am. And then if you can, if you can find out who I actually am, that'll be cool. But we'll kind of do like a reveal of who Hank Hackerson is, and it should be fun. It should be a cool journey as we go along here. So make sure you like, subscribe, turn on that notification bell, and drop a comment. It's your boy Hank Hackerson at Hank Hacks Hackers. If no one else loves you, Hank loves you. Love, peace, and chicken grease. I hope you enjoyed this video, and I hope you got a lot of value out of it. And I will see you in the very next one. All right, later.